Hi, in this video, we'll talk about collections topic in Java. So we'll see one by one. So first we'll talk about variable. So what do you mean by variable? A variable is a named reference to a memory area where value of the variable is stored. So if you want to store some values, you can use variables. So if I want to store 10 here, so I'll use int I is equals to 10. So int is data type, I is equals to variable name, 10 is actual value, which I want to store in the memory. So this is how you will store the value. But here it will store only one value, right? Only 10 I can store. So if I want to store more than one value, so variables will not useful for that purpose. So variable can hold only one value. So if you want to store or hold more than one value, so what will you do? So will depends upon the arrays, right? Arrays are objects which store multiple variables of same type that are referred by a common name. So that we already discussed in detail in our one of our previous videos, arrays. So this is just a definition that it can hold or store multiple variables of same data type. Okay, so if this is an array, I stored 5, 15, 26, 45, 85, 124, 56, 25, 63, 3, these many values. So 10 values. So and these values can be represented using index from 0 to how many values you have, that many. So it will start from the index 0. So here 0 to 9 means I have 10 values. I hold 10 values in this array, right? So we can hold one value, we can hold multiple values, right? We have two provisions. With the help of variable, you can store one value. With the help of arrays, you can store more than one variable. Okay, then why we need to talk about collections here, right? What collections exactly? So before jumping into the collection, we'll see what are the drawbacks of arrays. So limitations of arrays. Okay, so if you know limitations of arrays, then we'll jump into the collections. What are the advantages over arrays? And we can discuss one by one in detail. So arrays are fixed in size. So we cannot increase or decrease the size of the array according to our requirements, right? So we already discussed all these things. So arrays is fixed in size. While initializing itself, you need to mention how many values you are going to store. Means the requirement you should know in advance, right? So once you declare, you cannot increase or decrease the array size. So that is one of the limitations. To use arrays, we should know the size of the array in advance, right? So because of that, we cannot increase or decrease the size. Arrays can hold only homogeneous data type of elements. Homogeneous. So homogeneous means only same kind of data. If you want to store only, you can store only integer values. You can store only string values. So whatever it is the data type, you can store only that kind of data type in the array. So you can create int array, you can create string array, you can create boolean array. Okay, so same kind of data elements you can store in an array. Arrays are not implemented based on any standard data structures. So no ready-made methods available. Need to write our own logic to fulfill our requirements. It increases the complexity of the programming. So what do you mean by it's not implemented on any data structures means? So underlying there is no data structure. Because of that, if you want to perform some operation on arrays, I want to sort an array. Okay, so I cannot sort directly. There is no readily available method to implement on this array. So if you want to sort an array, you need to write your own logic to sort that array, right? So if you want to do that, you need to write so much of code. So it increases the complexity of the program. Okay, so these are all the few limitations of arrays. So to overcome these problems, Java introduced collections concept. Okay, so we have seen variable, we have seen arrays, and when you come to the collections, those two are not sufficient our purpose, our requirement. According to our requirements, it is not sufficient. So because of that, they introduce collections. So what do you mean by collection? So collection is to represent a group of individual objects as a single entity. So the same thing, it can hold multiple values, right? Collection is to represent a group of individual objects as a single entity. So if you want to represent as a diagram, you can see here. So the entire thing is a collection. This is the blue color is collection. So inside the collection, it holds multiple values. Those are objects. You see 1, 2, 3, 4, 5, 6, 7, 8 objects it holds. So to represent a group of individual objects as a single entity, that is called collection. In simple terms, it can hold multiple values. So that is called collection. So what is collections framework? Okay, there is another word called collections framework. So what is that? The Java collections framework provides a set of interfaces and classes to implement various data structures and algorithms. So we are talking about collection. So collection is to represent a group of individual objects, a single entity. But to achieve that collection, how you can achieve that? So for that, we have multiple interfaces and classes that collectively called as collections framework. Okay. So in our next videos, we will talk about all collections, interfaces, and classes in detail. So we are talking about there are few limitations to arrays. So what is the advantage when you go for collections? Okay. Collections are growable in nature. So we can increase or decrease the size based on our requirement. So here no need to provide the collection size in advance. In the runtime, whenever you're using, you can increase or decrease. So collections are growable in nature. Okay. Means it is dynamic. And collections can hold both homogeneous and heterogeneous elements. Homogeneous means same kind of data types. Heterogeneous means combination of, means you can store at a time integer, string, boolean, combinations of these elements you can store in collection. Okay. So every collection is implemented based on some standard data structure. So we have ready-made available methods for each requirement. We just need to use the suitable method according to our requirement. So every collection is implemented based on some standard data structure. So if you want to sort the collection, okay, then no need to write your own logic. So you have readily available methods. You can directly implement those methods on your collection and you can achieve whatever you are expecting. Okay, that is the advantage when you go with collections. So now we talk about difference between arrays and collections. So when you talk about these differences, as we already discussed, arrays are fixed in size, right? Fixed in size. With respect to memory, arrays are not recommended to use, right? We don't know how much elements we are going to store. So because of that, with respect to the memory, arrays are not recommended to use. With respect to performance, arrays are recommended to use. Okay, if you know how many objects are you are going to store, okay, if you know that in advance, then go with arrays, then performance will be improved. So arrays can hold both primitives and objects. Okay, it can hold primitives and objects. Arrays concept is not implemented based on any standard data structure. So ready-made methods not available. Okay, so these are all when you talk about arrays. So collections are growable in nature, right? So you can increase in the runtime, dynamically you can increase. With respect to memory, collections are recommended to use. So opposite. With respect to the performance, collections are not recommended to use, right? So opposite of arrays. But collections can hold only objects. So here arrays can hold primitives and objects, but collections can only hold objects. Collections implemented based on some standard data structure. So ready-made methods are available, right? Ready-made methods are available. So that is the basic differences between arrays and collections. So if you see the collections in detail as a diagram, so you can see that parent on the top level interface is collection. The name itself is a collection. So this is the parent interface. So from this, there are three interfaces implemented, means child interfaces: list, set, queue. Okay, list, set, and queue. These three child interfaces under collection. So when you talk about the list, under list we have multiple implemented classes are there. So these are classes. So those are array list, linked list, vector, and stack. So these four are implemented this list interface, right? So when you're coming to the set, you have two child classes, means one is class, one is interface. Hash set, sorted set. Sorted set, again, it is an interface. Under that, you have two more classes, navigable set, tree set. These are classes implemented this sorted set. Here, hash set and linked hash set. This is child class of this hash set class. Okay. So coming to the queue. Queue has multiple classes. One is priority queue and blocking queue. Under the blocking queue, you have two more classes. Those are priority blocking queue, linked blocking queue. So these are all comes under collection interface. Okay, these are all child of collection interface. So let me clear this. So this is one part of collections framework. So apart from collection, we have one more called map. Okay, map is also part of collections framework. So map is parent interface. So under that, you have multiple interfaces. Those are hash map, weak hash map, identity hash map, sorted map is the interface, and hash table is a class. Okay, so hash map has one more interface called linked hash map. So under the sorted map, you have two more interfaces called navigable map, tree map. So under the hash table comes under from the dictionary also. This is abstract class. So hash table is class. Under this, we have one more class called properties. Okay, this is the hierarchy of map interface. Hash map, weak hash map, identity hash map, sorted map, and hash table. Okay. So apart from these collection and map, we have few more things under the collections framework. So those are utility classes in collections. Okay. So what are utility classes? The utility classes consist exclusively of static methods that operate on or return collections. Means if you want to perform some specific operations on collections. Okay. So some operations on collections, then you can use these collections utilities. So we'll discuss all these things whenever we need to use. So, but inside the collections arrays, we have some static methods which are helpful to perform some operations. So readily available methods we are discussing, that those we can get it from these utility classes. Like apart from the implemented classes. So here also you'll get some utility methods, which are very handy when you write programs. Okay. So, and then sorry. Let me clear this. So when you talk about another one, so cursors in collections. Okay. We have utility classes. The same way you have cursors. So if you want to get objects or elements one by one from the collection. Okay. If I want to get elements or objects one by one from the collection, then we should use cursors. In the cursors, we have three types of cursors. One is enumerator, one is iterator, another one is list iterator. So three are interfaces. Okay, with the help of these things, we can iterate over the collection and we can get one by one element. Okay. So we have one more. What is that? Sorting in collections. Okay. So to sort, Java provides two interfaces to sort objects using data members of the class. Those are comparable, comparator. Both are interfaces. With the help of these collections, we can sort the collections. Okay. So collectively, what are those? We can say, so collection interface. Okay. And it's child, map, utility classes, cursors, the sorting, So all these things collectively called are collections in Java. The collections framework. It includes all these things. Okay. So we'll talk about each and everything in detail in our upcoming videos. So here just theory about what is collections framework, what is the advantage when you go with collection framework, and what are all comes under collection framework. Okay. So let me clear that. So what are the possible interview questions from this topic? So what is collection in Java? What is collections framework in Java? What is the difference between arrays and collection? Name few of the collections, collection interfaces and classes which you know. What are utility classes? What are cursors? What are sorting interfaces in Java? So you may face these kind of interview questions. Okay. So this is all about collections introduction. That's all in this video. Thank you. Hi, in this video, we'll talk about collection interface in Java. So what is collection interface? What it contains, we will discuss in this video. So if you see the diagram, which we already saw in our introduction part of collections. So the top root level, this is the one collection we are talking about. So the collection interface. So what is collection? Collection is the parent or root interface in collections framework. Okay. So this is parent or root interface, right? So in the collections framework. So collection interface defines the most common methods. Okay, it defines the most common methods which are applicable for any collection object. So as it is parent and it is an interface, it will contain multiple methods. So those methods are applicable for each and every collection which is so implements this, right? Is an interface. So the other classes implementing this, interfaces, extending all these things can be used, all the methods which are available in this collection. So it is the parent or root interface in collections framework. Collection interface defines the most common methods which are applicable for any collection object. Okay. So from the table you saw so many things under this collection, right? So on the methods which are there, methods which are there in this, all applicable for all this list, set, queue, everywhere it is applicable. Okay. So methods defined in collection interface. What are the methods inside this collection interface? Right. So the first one is Boolean add inside this object. So it contains multiple objects, right? Add object. So the add method is to add single object to collection. So it will add only single object. Right. So you have one more method called add all. So this add all, the parameter you need to pass, add all means more than one element. So more than one element, how you will represent? So it will be in the form of collection. So to this collection, you can add another collection. Okay. So to add a group of objects to collection. So here group of objects means again another collection. Right. So another collection you can say, so to the collection, another collection you can add. So another method is remove. Okay. So remove the object, to remove single object from collection. So if you want to remove single object, you can use this remove method. And the return type of these methods are Boolean, Boolean, Boolean. Means if it is added, it will return true. If it is not added, false. If it is added, all the elements returns true, otherwise false. The same way it removes, then true, otherwise false. The same way you have remove all. How you have add all and adding the collection, the same way here also same thing. So to remove group of objects from the collection. Okay. Boolean retain all, here also collection C, the same way collection, but here to remove all objects except those represent in C. So except this collection, you remove all other elements. Right? Whatever you mention in the as a parameter, only hold this. The remaining things you remove from the collection. Okay. So clear. Clear means to clear all objects, all the objects from the collection. Okay. If you want to remove all the objects, you can use this clear method. It will clear all the objects from the collection. So we'll see all these methods by taking an example in our upcoming videos. So these are 1, 2, 3, 4, 5, 6, 7 we discussed. 6 we discussed. We have few more. So again, Boolean contains object to verify collection contains mentioned object or not. Means we have a collection. Inside the collection, I want to verify whether the object is there or not. This object is there inside this collection or not. For that, we'll use contains. The similar way you have contains all, and it is collection. So another collection. This collection contains another collection or not. To verify collection contains group of objects or not. So that with the help of contains all, we can verify. So Boolean is empty. Is empty means to verify collection is empty or not. So you have a collection, inside that you have objects or not, that you want to verify. With the help of is empty method, is empty true means that is you do not have any elements inside the collection. If it returns false means you have some elements inside the collection. So size of the collection, right? How many elements are there? To get the size or number of objects of the collection. Object array to array. So you can convert a collection to an array, right? If you want to convert your collection to array, you can convert. So we have seen in our previous video that cursors or iterator. So iterator to get all the elements one by one from the collection, and the return type of iterator method is iterator only. Okay. So to get all the elements one by one from the collection. So by taking one example, we'll discuss all these methods. Okay. So here, if it is collection, no concrete class available which implements collection interface directly, right? You have interface. So interface will have abstract classes, right? Abstract classes. So if you want to use those, we should have one child class which should implement this interface, right? So, but here there is no such class available which implements collection interface directly. Okay. So I mean directly means you say if you go to the diagram, you see that under the collection you have 3 more interfaces. No class in in the first level. Okay. In the first level you do not have any other concrete classes. We have 3 interfaces. So because of that we are saying there is no concrete class implemented this collection. So in the same way, no direct method available. You see that? No direct method available in collection interface to get the objects. Right. So there is no concrete class available which implements collection interface directly. No direct method available in collection interface to get the objects. So we need to remember these 2 things. So apart from that, what could be the possible interview questions from here? So what is collection interface in? So this is interface, right? Collection interface in Java. What are all methods defined in the collection interface? So whatever we discussed till now, you can explain with one example. Okay. So this is all about collection interface. So that's all in this video. Thank you. Hi, in this video, we'll talk about list interface in Java. So what is list? What is this interface? What it contains? We'll discuss in detail. So the diagram which we already saw in our previous videos. So this is collection tree. So collection is the root or parent collection for this. So under this we have list. So we are talking about this list. You see this list we'll talk about. Okay. So this is also one of the interfaces under this collection interface. So list is child interface of collection, right? This list is child interface of collection. It is used to represent a group of individual objects as a single entity where we need to remember these duplicates are allowed and insertion order preserved. So this is 2 important points we need to remember. So the reason is this, it is used to represent a group of individual objects as a single entity means what is that is collection is already discussed. That is very generic term, high level. The list is also under the collection. It can hold multiple. It can also hold multiple values. But what is the a specialty of this list, right? So where it can hold duplicate values. It can hold duplicate values, and insertion order preserved means how you insert in the same way it will insert into that, the same order it will insert into the list. Okay, these two things you need to remember. List means it will allow duplicate values, and the insertion order is preserved. So duplicate objects can be differentiated using the index. Okay, so I'm saying duplicate values, right? So duplicate values means here also you'll get the with the help of index only you'll get the information, right? In the first index, in the 10th index, we have the same value. So how you will differentiate? Using the index. This is first index, this is 10th index. With the help of this index, you can differentiate the duplicate values. Okay, so what we understand from that, so index will play major role in the list. So with the help of index only, you'll differentiate the values, you'll get the values. Because of that, index will play major role in the list. Okay. So what are the methods defined in list interface? So we have so many methods in the collection, right? We already saw in the collection few methods in our previous video, collection interface. So apart from that, it has its own methods. So it will get the methods from here, and it has its own methods. Okay, so why it is that void add? Okay, there also add, we have one more add, but what is the difference between these two adds? There add object wo, but here int index means in which index you want to add your element. You can specify I want to add this element at particular index. Okay, that is the extra thing you have in this list interface. So to add an element at a particular index, and the same way Boolean add all, the same thing. Previously we have seen only collection C, but that collection C from which index it has to add. So that you need to represent with the int index to add a collection at a particular index. Object get. Okay, you need to get one element from the list. For that you will use get int index. So with the help of this index, to get an element which is at a particular index, first index value, 10th index value, 20th index value, I need to get. So 10th index means I will represent a get of 20. But then I'll get the 10th index element. So that is all about get. So object remove, how you get the element, in the same way you can remove at particular index. So you see that here also index. So to remove an element which is at particular index, I want to remove 5th index value, something like that. Okay. So if you want to, you have one more method called set. Int index object new means, so to replace an element present at specified index with provided element. So in the third index, I have value 5. I want to replace this 5 with 10. So then if you give that third index value 10, then with this 5 is replaced with this 10. Okay, that is all about set method. But if you observe all these methods, you have index, 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 index. So because of that, I told in the previous slide, so index will play major role in list, right? In all the methods, we have index as a parameter, right? So apart from this, we have few more methods. Int index of object. So till now, with the help of index, you get the element. Now you provide the element and get the index of that particular element. So I have a value called ABC in the list, but in which index this ABC value is there, object is there. So that if it is in third index, then it will give me index value. So because of that, it will return integer value, right? So that is. So, and what is the specialty of this index of is if you have duplicate values. Okay, so which I have ABC here and I have ABC here. Okay, in between I have something like that, x, y, something. So 0, 1, 2, 3, 4. In the 0th index, in the 4th index, I have same values. But if I say int index of ABC, I'll get this index or this index. So that is first occurrence of, means I'll get only 0. Okay. So if you mention last index of, same thing. Okay. Last index of, you can put index and this one. So returns the index of last occurrence. Okay. How we have here first occurrence, here you have last index, last occurrence of that. If you want to find the in middle, in between, in the middle of this collection, then you need to write your own logic. Okay. So apart from that, we are saying that cursor. Here we have list iterator. With the help of list iterator, returns a list iterator over the elements in this list. So we said one by one. One by one, you can loop through all these values, and you can do whatever you want. You want to print, you want to perform some operation on that object. That is depends upon your requirement. But you will get one by one element with the help of list iterator. So these are all the methods available in list interface. Okay. So what are the possible interview questions from here? What is list interface in Java? So what are the methods defined in the list interface? Okay. That's all in this video. Thank you. Hi. In this video, we'll talk about array list in Java. So this is a class in Java. So we'll discuss in detail about array list in Java. This is one of the classes in collections framework. Okay. So the same diagram which we saw in our previous videos also. So at high level collection, and inside under that you have 3 interfaces. Inside the list you have array list. This is what we are going to talk about, right? This is array list. This is a class. So we'll talk about this thing. So this is this implements list interface. Okay, child of list interface. So what is array list? So array list is a class which implements list interface. Right, this is child of list interface, which implements. So the underlying data structure for array list is resizable array or growable array. So in one of our previous videos, when you're talking about the difference between collections and arrays, so collection is implemented on top of some data structures. That is what discussed, right? So in that context, array list is means the underlying data structure behind the array list is resizable array or growable array. Okay. So duplicate elements are allowed. So this is what we discussed list interface, right? In the list interface also, we have seen what is the specialty of list is it will allow duplicate elements. So duplicate elements are allowed, and insertion order is preserved. So which order you inserted the elements to the list, and the same order they are inside the list. So that order is preserved. So heterogeneous objects are allowed. So we already discussed at the high level is what is the purpose of going with collection size. One of the advantages is it will accept heterogeneous objects, means you can put multiple data type of elements inside a single collection. So you can add one integer, you can add one string, you can add one boolean, something like that. The mixed elements you can store inside the collection, means array list. So null insertion is possible. If you want to insert null value also, it will allow. So this is the brief information about array list. It's a class which is implements into list interface. It is developed on top of this, means data structure is called resizable array or growable array. So duplicate elements are allowed, insertion order is preserved. It allows heterogeneous objects, and null can be inserted into this array list. Okay. So there are, as it is a class, it has multiple constructors. So one of the constructor is the simple one. Array list is a class, right? Class. So object reference, new class, means it is the basic, like basic constructor. Array list is equal to new array list. Okay. So this is how you will initialize an array list. It will create, the moment when you write something like this, what it will do when you're programming. So it will create an empty array list object which default initial capacity is 10. Right? We are saying it will hold multiple values, right? So if it is holding multiple values, means the moment when you create an array list like this, it will create an array, sorry, whatever it is. So 1, 2, 3, 4, 5, 6, 7, 8, 9 means. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So with this initial capacity 10, it will create something like this. Okay, but you will not have any elements inside this, all are empty. So empty array list object with the default initial capacity 10. So this is how it will create. If array list reaches its max capacity, then a new array list object will be created with a new capacity by following formula. Right. So what happened? I created one array list, something like this, and I keep adding the elements. So we have add method, right? With the help of add method, I'm adding. So I added 10 elements, but now I need to add 11th element. Okay, I need to add 11th element. Then the behavior will be how it is. So if it is a list, this is the L object, it will reference to this one. So if you need more than 10 elements, so what it will do, the moment when you try to insert 11th element, so it will create another array with more capacity. Okay, with more capacity. What is that capacity? For that, there is a formula that we'll see. Okay, so it will create another one. So it will remove the reference to this, and it will give the reference to this object. So then it can be destroyed with the help of garbage collector. Okay, so whenever garbage collector sees this object, if it is not used by any other, I mean, if you do not have any reference to this, it will destroy the garbage collector, this object. But what is the difficulty here? So the moment when you create more than the capacity, then it will create another array list, and it will keep copy all the elements into this 10 elements, then 11th will add. If the moment it reaches the end, then again it will create another big array, and it will copy all the elements from here, and it will add the which element you want, and the reference will be removed here and given the reference to this one, and it is garbage collector will destroy this object. This is a expensive task, right? So because of that, performance is decreased when you compare to arrays. That is what we discussed in one of our previous videos, this differences between arrays and collection. So collections are, if you concern about memory, you need to go with collections, but performance will be decreased. If you go with arrays, you need to know the size of the array in advance. So that is lacking in the memory level, but performance wise it is fast. Okay, so performance wise it is fast. So this is how it will internally work. So what is that formula? Means how the new capacity will work. So this is the formula. New capacity is, so the new capacity is current capacity into 3/2 plus 1. So the moment when you reach 10, if you try to 11, so what is that? 10 current capacity into 3/2, right, plus 1 means 2 5 is 5 3 15 plus 1. So this is with the 16 elements. At the moment when it reaches next one, so then 16 into 3/2 plus 1 to 8 8 3 24 plus 1 25. This size is 25, right? If it is 25 into 3/2 plus 1, right? But there is no exact we cannot do 12.5. So but this is integer, right? So it will take 12 into 3, 36 plus 1, so 37 elements. If it is reaches, it will create another array list with 37 capacity. Okay, this is how it will create, but each time it will copy all the elements into the new one. So that is expensive, and because of that performance will be very low. Okay, this is one of the constructors. Array list L is equal new array list. So here another one. So array list L is equal new array list of int initial capacity. So if you know the capacity in advance, so how it is very similar to array. If you know the capacity of array, very simple. I'm going to store 100 elements. If you initially say 100 elements, then the moment it creates, it will create with 100 capacity. Otherwise, whatever we saw here, right? First 10, then 25, then 36, then 10, 16, 25, 37, something like that. It keep increase that. It needs to copy all the times. So performance will be decreased. So because of that, if you try like this, if you're going to add 100 elements, So create with 100, then while creating itself, it will be with 100 capacity. Then there is no need to create another one and no copy all these things. This can be avoided. That is the advantage with this constructor. Okay. It will create an empty array list object with specified initial capacity. That is what we are discussing it. Empty array list with capacity 100. If you mention whatever it is. It is an efficient way if you know the capacity. So if you already know and if you mention that one, that is what performance will be increased, right? So that is what we are discussing here. Okay, this is another constructor. So you have one more constructor. So array list is equal new array list of, it will accept collection. Another collection you can give as a, so it creates equivalent array list object for specified collection object. Okay, the similar, whatever collection you give, with similar, it will create array list. If you give another collection, which are there are so many collections in that diagram, right? If you give another one, it will convert into the array list, similar array list. This constructor will be helpful for interconversion between collection objects. That is what, if it is, you provide another collection that will be converted to the array list. That is the advantage when you go with this constructor. Okay, so these are all the three constructors available in array list. So according to your requirement, you can use any one of these constructors. Okay. So all the methods present in the array list are non-synchronized. So all the methods present in the array list are called non-synchronized. So multiple threads can allow to perform operations on array list. So if it is non-synchronized, so multiple threads can access this array list. So relatively performance is high because threads are not required to wait. So if it is synchronized, so until one thread completes, another thread cannot access this one. So there it will take more time to finish the activity. But multiple threads means at a time, multiple threads can try to access this one. So because of that, threads are not required to wait. So relatively performance is high. So collections dot synchronized list can be used to get the synchronized version of array list. So all the methods are non-synchronized. So it is non-synchronized class. So if you want to convert this non-synchronized class to synchronized version, then we already discussed in one of our previous video that this is utility class. Right, utility class. So with the help of this utility class, this is the static method available inside the utility class called synchronized list. With the help of this method, you can convert your non-synchronized array list to synchronized version of array list. Right. So if you see that diagrammatic way, so here I created array list is equal to new array list, and a list is equal to collections dot synchronized array list, and you need to pass this array list object here. So then what happens with the help of this non-synchronized array list, it will create synchronized list. Okay, and this list is parent of this, obviously it can hold that information. So if you see that this is non-synchronized version, this list is synchronized version, right? With the help of collections utility class, one of the methods available in that is synchronized list. We can convert this non-synchronized version to synchronized version of this list. Okay, so a few more points about array list is, array list is defined in java.util package. Okay, this is available in java.util package. If you want to use array list, you need to import java.util in your program. Array list is best suitable for retrieval operation. Okay, so you have n number of elements inside this, right? But with the help of index, you can directly get that, whether it is in 1000 location also, if it is in 0th index, 1000 location index or 0th index, you just mention get of 1 lakh, right? It will directly get the value from there. If you mention get of 0 also, same time. So best suitable for retrieval operation, if you want to retrieve some information from. But this is not the best suit for frequent insertion or deletion operation in the middle of array, as it requires multiple shift operations internally. So what happens? Let's assume you have something like one array list, 1, 2, 3, 7, 8, 9, something like that. So with here, if you try to add one element in between, 1, 2, 3, 4 means third index. So what happens here? It will create, but these things will be shifted one by one. Right? It has to go to fourth index, it is fifth index, sixth index. If you try to insert one more, it has to go to fifth index, it's sixth index, seventh index. It has to shift right. Right. So that operation is costly. Means here only 3 elements. If you have 1 lakh elements, and if you are trying to add in the second index, so if you try to add in the second index, you have remaining 99,998 positions. It has to shift. If you do that operation more than one time, so every time you need to do this operation. So this is not best suit for frequent insertion or deletion. If you try to remove this element, so obviously it will come to this one, left shift. This is right, you need to do left shift. So the same thing, right? If you add, it will move to right side. If you delete, it will come to the left side. So but operation is same. So if you have so many elements, it will take so much of time, right? So this is not the best suit if your requirement is insertion or deletion. But if your requirement is only getting the data, then you can go for this. Best suit for retrieval, not best suit for insertion or deletion operation in middle. Okay. So what could be the possible interview questions from the array list? So what is array list in Java? What are the different constructors available in array list? So whatever we discussed, we can explain that. Okay. So in our here we just saw only the theory of array list. In our next video, we will, with the help of all the methods in the list interface, collection interface, right? So if you go to the top, the diagram, right? In here, so you have a few methods in the collections interface. You have something in the list. So you will get everything from here and here, right? So how you can use all the methods available in list, how you use in this class, and how you perform operations on a list, how you to create a list, how to perform all the operations with the help of those methods, we will see in our next video. Okay, so that's all in this video. Thank you. Hi, in this video, we'll see array list example. So in our previous video, we discussed about array list in theoretically important points, how you need to create an array list, what are the constructors available in array list, all these things we discussed. So in this, we will see with the help of one example, we'll understand everything. Okay, so let me go to Visual Studio Code. So here, first, we need to initialize array list. For that, array list al is equals to new array list. Okay, so this is how we need to initialize an array list, right? So now we'll go to the command prompt. I'll try to execute this. Okay, so we'll try to execute this. I'll try to compile this. Java C array list demo.java. You see that cannot find symbol. Array list al initial what it is saying, class array list location class array list demo cannot find symbol. It is saying cannot find symbol. The reason is, so we already discussed, it is array list is available in java.util package. So we need to import that. Okay, import java.util.stall. Okay, so then if you try to compile now, you see that no errors, right? So this is how you need to implement, you need to import the java.util package to work with array list. So now I created. Now what I need to do, I need to add elements or objects to this. Okay, to this array list. How you do that? We have one of the methods called al.add. Add is a method. So I'll add Java. Okay, so al.add, I will add one character A. al.add, what is that? One integer 10. al.add one boolean value true. Okay, So heterogeneous objects can be added to the array list that we discussed, right? So because of that, I am adding different type of elements, one string, one character, one integer, one boolean, right? So how you will come to know that whether it is perfect and now all the elements are added to this array list. So array list can be represented like how in the square bracket. Okay. Inside this you will find the objects. So obj1 comma obj2 comma etc. Something like that. It will show on the console. Okay. So let me try to print this system.out.println al. Just I am printing this object. Okay. So let me go back here and let me execute this directly. Okay, I'll remove the C. Execute. You see that Java A10 true in the square bracket, right? What it printed here, this is what it printed. You see that Java A10 true. How, which order you mentioned? The first Java, then A, then 10, true. True means the insertion order is preserved, right? The same order how you added, it added to the array list, right? That is called insertion order preserved. So now this is one way, right? This is using normal collection method add, but in the array list you have one more add method. So add elements using index, right? That is what we have seen in our previous video. Index is very important array list. So al dot add. So in the 0th index, I'll add first simply. Okay. So now I will try to print this. Okay. I will try to print this. So what happens here in the first position? 0th index first will come. This will move to the next, right? It will shift to the next index. So if I execute, I need to get the first Java A10 true. You see that? First Java A10 true. That is how it added at the 0th index. This way you can add the elements to your array list. Okay. So now I'll give a space here. Now what method we can see? Another way means add all method we'll see. Means another array list I will add. So for that first I need to create array list, right? Array list al1. Okay. New array list. Right. For this I'll add al1 dot add. What is that? I simply say put ABC. Random string dot add PQR. Something like that. I added 2 elements to this. Okay. So now what I'll do, add all method, right? So add multiple elements. This is what add all. Add multiple elements. For that I'm using another array. So what I'll do here, al dot add all of al1. This is what, right? So collection I'm adding. So now I'll try to print again al. Okay. I'll try to print again this al. So now for this al object, we added al1 object. So at a time ABC PQ are added. So where it will add, we will see. Okay. At the end it will add. You see that? First Java 10 A10 true till here, and another array list I added. It added at the end. So that is what the behavior. Right. This is how it will add. Add all method will work. Add all multiple elements. Multiple means at a time I ABC PQ are added to this array list. Okay. So now what we can see, access elements. Okay, I want to add this particular element, access or get elements. So how you can add, get that one? So system dot out dot println al dot, we have one of the methods called get. So using the get, I need to provide the index. So I'll say third index value. Okay, in the third index, what is there? 0, 1, 2, 3. So it has to give me the output as 10. Okay, I'm accessing the element using index. So if I try to execute this, the last output is using 10. Right. So you can mention what index you want, in which index element you want. You just mention that in the get method. So that's simple it is. So after that, change elements, change or update. Okay, update elements. What is that method we have? We have set method, al dot set, and what are the parameters you need to pass? In which index value you need to change. I want to change the 0th index value from first to start. Okay, I just changed what? The 0th index value is what? First. Now I'm replacing first with start. Okay, so let me execute this and see the output. You see that previously it is first, after set method it changed it to start. The remaining elements are same, but it is updated. The 0th index value is updated with the help of set method. Okay, that is the usage of set method. So remove elements. You can remove the elements, right? So what I'll do, al dot remove. So which element I want to remove? You need to provide the index. So as I already recently added this first start at 0th index, I will remove. Okay, I will remove 0th index. I will print again. Okay, I'll print again. So previous output is what? This one. So previous output is this one. So here, what it has to do, this start should be removed. It has to print from Java only. The reason is 0th index value I removed. I'm expecting this output. Okay, so execute this. And you see that start removed, and the last is Java 8 and true ABC PQR. Right, this element is removed with the help of remove method, and I'm providing the index, 0th index value element I want to remove. I removed. Okay, so now after remove elements, I need to get the size of my array. Okay, size of my array list. So system dot out dot println al dot size. Right, that's it. Al dot size. What is the size? 1, 2, 3, 4, 5, 6. So it has to print 6. Size of my array, current array list is 6. So let me execute this, and we see the output. You see that 6. So right, we have 1, 2, 3, 4, 5, 6 elements inside this array list. Because of that, size is getting 6. Right, I'm expecting the 6. I got the 6. So after that, whether this array list contains particular element or not, contains element. Right. For that, what it will return contains means it will return true or false. So system dot out dot println al dot contains what element I can check. I'll check Java. Java is there inside this array list or not. So it has to print true. Okay, it has to print true. The reason is this contains Java. Okay, so if I try to execute the same thing, it has to print true last. You see that? True. And if it is not there, okay, if the element is not there, I'll just give Python. Simply I'll give Python, which is not there in the array list. So it will return false. Obviously it will return false. Let me execute and see. Last output will be false. You see that? False. So this is how contains will work. Contains means whether a particular specified element is there inside that list or not. Okay, contains element. So E is empty, whether my array list is empty or not. So this also returns what? It is also returns Boolean. AL dot is empty. Whether this array list is empty? No, right? We have 6 elements inside that. So it will return false, obviously. Right? AL dot is empty means my array list is not empty. It has 6 elements. We have seen the size, right? So if it is not empty, then it will return false. So let me execute and see. The last output should be false. You see that? False. This is for previous element contains or not. This is for what? Empty or not element. So false. So it is not empty. It has some elements. Right. So then what we can see here, one more method. Yeah, index of particular element. So index of particular element. So first we'll see add duplicate elements. Okay, add duplicate elements. Right. So add duplicate elements. AL dot add. Again, I will add 10. 10 already there. Okay. So I'll try to print the array list. Simply printing. Okay. Simply I'll print. I'll see what is the output. So it has to accept duplicate value, right? So I should have 2 10 values inside that. You see that 10 here, 10, the last element also 10. So the moment when you add, it will be added at the end, right? So this is how here and the last element. The duplicates are allowing. Now what I'll do, index of. Okay, index of. Index of. So how we can write this is, sorry, again system dot out dot println. So index of AL dot index of which element? 10. Okay, this element, 10 element index. What is that? It will give me first occurrence, right? First occurrence. Okay, then 0, 1, 2. It has to give me the index 2. The object 10 index is 2. So if I try to execute this now, the last value should be 2. You see that? 2. So index of particular object inside this array list, it will print, it will give me in the form of what? Integer. Okay. Now, I want to print all the values one by one. Now I'm printing all the values at a time. Right, I want to print Java, A, 10, true, ABC, PQR, 10, something like that I want to print. So we said some cursors are available, right? Right, iterators. So cursors print values one by one using list iterator. Okay, list iterator. So we'll see that. So what is that? List iterator. Okay, so you need to create an object. List iterator. Iterator is equal to al dot list iterator. So it should be small. It's a method. So list iterator. Right. So on this we need to iterate through. So I'll use while iterator dot, one of the methods called has next. If it is has next element, print that next element. Okay, so system dot out dot println iterator, sorry, iterator dot next. Okay. Inside this array list, if it has next element, print the next element. To verify whether next element is there or not, that method is has next. So it will return Boolean value. If it is true, inside that go, and to print that next element, the method is next element. That's it. Okay, now it will print Java 10, A, 10, true, ABC, PQ, 10, one by one. Okay, so let me execute this. You see that Java A, sorry, 10, true, ABC, PQ, 10. So one by one element again. So with the help of for loop, for each loop also, you can print. But here my intention is you can use cursors to print one by one. So instead of this, you can use for loop, for each loop also. Right, no problem. And next, what we can discuss, contains all. Contains all. So contains all means what you need to provide another collection object. What I have collection object AL1, right? So system dot out dot print ln array list dot contains all of AL1, right? In the AL1, what we have, this is separate array list we created with ABC and PQR. These elements are present, contains this array list, right? These are contains. We only added using add all method. So it has to print true, right? AL contains all AL1. So whatever the elements inside the AL1, the same elements contains in the AL also, right? So then it has to print true. Let me execute. The last value should be true. You see that? True. The reason is AL1 contains what? In the starting we created one more. You see that AL1. AL1 contains what? ABC, PQR. These elements are there inside the AL object, array list object. Yes, ABC, PQR. So because of that, this it contains this collection. So because of that, it returning true. So now AL dot remove all. Okay, so we use remove all. So AL dot remove all of. I need to provide the collection. What is that? AL1 I'll remove. Okay, AL1 I will remove. System dot out dot print ln. Now you try to print the array list. Now what we removed from this AL1 objects means ABC, PQR I removed. Okay, ABC, PQR it should not print now. So you try to execute this. You see that here we have ABC, PQR. After remove all, you see there is no ABC, PQR. We have only Java A, 10, true, 10. Right, only these elements. It removed ABC, PQR. The reason is AL1 contains these two values. It removed. Okay, then obviously the output is what? The remaining elements. Okay. Now one more clear method. So clear will clear all the elements. It's remove all the elements. Okay. AL dot clear. So it will clear all the elements. If you try to print, okay, if you try to print this AL, now I do not have any elements. I do not have any elements. So empty array list means only square bracket. Inside that you do not have any elements. It will print like this, these brackets. Okay. So let me execute this now. You see that last one, empty braces means it removed all the elements inside this. Because of that, it became empty. Right, it will clear all the elements from the array list. Okay, so these are all the methods available in where, right? These are all available in the array list. So we have seen almost all the frequently used methods. So what we have seen add method. We have seen add with index. Okay, add multiple elements. So we have used get method to access. We updated, changed it using set method. We removed elements using index. We got the size of the array list using size method. We are verifying whether the particular element is there or using contains method. We verified whether the array list is empty or not. We added duplicate elements. We get the index of a particular element, and we iterated through using the cursors, and we printed all the elements. We verified contains all means other collection is available in this array list or not. So we removed the array list. Okay, array list means another collection. Okay, so as an example, I took array list. So I removed all the elements using clear method. So it is empty now. Right? We have seen all the frequently used important methods inside array list. Okay, so that's all in this video. So before closing, what could be the possible interview questions from here? So what is an array list? The very frequent question means, if when they want to ask, they can simply ask what is array list. We in detail discuss in our previous video. If you did not watch, you go and watch that video. I explained in detail. So example for array list. So we have seen all the methods which are there inside the array list. We took one example. We have seen all the methods with an example. Okay, so that's all in this video. Thank you. Hi, in this video, we'll talk about linked list in Java. So linked list is a class. So we'll go and see that where we are. So in the collection, so this is the linked list, comes under list interface. So we are talking about linked list. So we'll see one by one. So linked list is a class which implements list interface. So that is what we have seen here. See list, it implements list interface. So the underlying data structure for linked list is doubly linked list. In the linked list, we can insert duplicate elements. So duplicate elements are allowed. Insertion order is preserved. So in which order you insert the data, in the same order it will be stored. Heterogeneous objects are allowed. We can add different type of data types to a linked list. Null insertion is possible. So we can insert null values also into the linked list. So if you talk about diagrammatically how the implementation will be, so if you see this diagram, is that elements will be not in order. So it will not be in an order. So A here, B here, C somewhere, D somewhere, and the link between these two elements. So every element will have the next element address. So here it will have B address, and here previous element address. Okay, so here next element. So here B will have A address as a previous element address, and in the next it will have C address. In the same way, C will have B address, and here D address. So that will hold that information. So this is how it will implement internally. The data will be stored something like this. But if you remove some element in between, okay, if you remove some B you removed. If you remove B, then this linkage will be gone, and it will add to the next element like this. Okay, so now it will have, C will have A address, right, and A will have C address. That's it. Okay, it will be replaced with the next element address information. So if you add something in between, so in between DE, you added Z element. Okay, then instead of it is pointing to E, it will point to Z, and the Z will point to the E. Okay, so it will not be there. So that simple it is. So if you remove, the link between two elements will be removed, and it will link to the next available element in the linked list. And the same way, if you add in between any one of the two elements, then it will point to the next element, how previously it is attaching to the next element, previous element, then the same way it will remove the reference to the E and it will add reference to Z, and Z will have the reference to E. And the same way E will have to the reference of Z, and Z will have the reference to D. So this is how it will implemented internally. Okay, so let me clear this. And if you move further, so what are the constructors available in linked list? So the simple one is linked list object is called new linked list. So this is the simple one, the base constructor. So it will create an empty linked list. Okay, it will create an empty linked list. And another constructor. So linked list of LL is equals to new linked list of the collection. It will, you can pass any collection. So it creates equivalent linked list object for the specified this collection object. Okay, this constructor will be helpful for interconversion conversion between collection objects. If you want to convert array list to linked list or something else to linked list, then you can use this. Okay, this is another constructor. So linked list is defined in which package? Java.util package. So almost all the collection will be in the Java.util package only. So linked list is best suited for frequent insertion or deletion operation. So in our previous video, we have seen array list. So if the something is like array list, if it is you filled everything, then it will create another big array list with some rule, formula, and everything will be copied from here to here, and it will be removed. All right. So big process. But here, insertion and deletion is, we already saw A, B, C. It will have the link between these two. If something remove in between, so it will directly have the reference like this. Very simple. Okay, one operation like. But because of that, this is best suited for insertion or deletion operation. Linked list is not the best suitable for frequent retrieval operation. Okay, it is best for insertion or deletion, but not best suited for retrieval operation. Okay. So usually linked list is used to implement stacks. Stack means last in, first out. Okay, last in, first out. And queues. Queue means first in, first out. Okay, so usually linked list is used to implement stacks and queues. For this purpose, linked list defined 6 more specific methods. Okay, what are those? So add first, adds the element at the first position of the linked list. Add last, adds the element at last position of the linked list. Get first. If you want to get the first element, you can use get first method. If you want to get last, a method will be used to get the last method from the linked list. Remove first and remove last. If you want to remove first element or last element, you can use these respective methods. Okay. So what could be the possible interview questions from this? So what is linked list in Java? So what are the different constructors? We have seen 2 constructors. One is the basic constructor, another one will accept collection. So what are the methods available in linked list? So apart from the regular methods, you can mention these 6 methods also. Okay, in order to work with stacks and queues. Okay, so that's all in this video. Thank you. Hi, in this video, we'll talk about linked list example. So we will see in our previous video, we discussed about linked list. So with the help of one example, we'll understand how linked list will work. Okay, let me go to the Visual Studio Code. So I created one of the classes called linked list demo. So we'll start writing the code and we'll see how it will work. So linked list LL is equals to new linked list. I created one object to the linked list. So first we'll see add elements, how we can add elements to this. So LL dot, we have add method. So adding Java. LL dot add we can add. So we already discussed about heterogeneous objects are allowed to add. So I'm adding different type of one string, one what is a one character, one integer. So one boolean and we can pass null. Okay, so I'll try to print this system.out.println linked list. So is it added or not, and it is displaying the information or not, we will see. So linked list demo and go to the command prompt. So Java linked list demo.java, you will get an error. We'll see why. Is that cannot find symbol. So we need to import the package we discussed at java.util package. So import java.util.star means everything from the util package. So if you try to execute now, you see that Java A10 true null, and in which order you inserted, the same order, insertion order is preserved, right? So this is how you can add the elements. Now we'll see add elements using index. Okay, so I'll try to add the ls.add, and in the first means 0th position I'll put first. Okay, and I'll add that, and we'll see so whether it is printing correct or not. So at the first position it should have first. Previously it is Java, now it is first. So with the help of index also you can insert. Now I want to add another, means more elements, like add another collection. Okay, so for that what I'll do, I'll take array list al is equals to new array list. Okay, array list al is equal to new array list. al.add, I'll add abc, al.add pqr, something like that, two random elements. So I'll try to print again. So first I need to add these elements, right? So add another collection, ll.add all of al. So here what I'm doing, I created another collection that is array list, and I'm adding that array list to this linked list, add all linked list. So now I'm going to print this one. So we'll see the output. You see that at the end we added ABC and PQR, these two coming from the array list, another collection. So we can add another collection to this. So now how we can access the elements? Okay, system ll.get is a method. So I'll try to print third index. Okay, print third index 0, 1, 2. It should print A. Okay, it should print A here. So let me clear this. Why it is printing 10? Sorry, 0, 1, 2, 3. Yeah, third index means 10, right? So it is printing third index. Okay, index starts from the 0. Now we'll see different other methods. So change elements, may update elements, or replace. So replace elements, how we can do that? ll.set. Which one? The 0th index we added first. Now I made it start. Okay, start, and I'll try to print the same thing. So now first you should replace with start. You see that previously it is first, now that is replaced with start. Right, this set is also working fine. Now we will see remove elements. Okay, now we'll say remove elements. So sorry, ll dot remove of whatever we updated, added, right? We'll remove the same thing, right? I removed start. Now we'll try to see. It should start from Java now. You see that Java start removed. Previously there is a another element. In the first element is start. Now I removed, so it is printing from Java. Okay. So remove elements. What we can see now. Remove elements, and then we'll see size. Okay. So ll dot size. Size is a method, and we'll see how many elements are there. You see, 1, 2, 3, 4, 5, 6, 7. So it is printing 7. Right, it is giving me the size. Now what are the contains? Okay, contains ll dot contains, which element we can verify. So Java, true, and the same way ll dot contains. I'll try to search what is a Python. Okay, but there is no Python in my list, linked list. So if I try to execute, you will see the last two. So what is that? Sorry, I put comma, so dot, so typo. So you can see that this is true and another one is false, right? And I need to verify whether my list is empty or not. Is empty. So ll dot is empty. No, I have 7 elements. It will give false, right? It is not empty. So you'll get 2 false. One is for previous one, and the last one is for whether my linked list is empty or not. It is not empty. Okay. So now we can use index of method. So ll dot index of, I want to get the index of integer 10. Okay. So we'll see what could be the 10, right? 0, 1, 2. It should print 2. Okay. So the last value should be 2 here in the output. You see that 2. The index of particular element is 2. And now I want to print the value one by one. Print the values one by one. So how you can do that? You have one of the cursors called list iterator. Okay. So is equals to new, sorry, linked list dot list iterator. So with the help of list iterator, we can do while iterator. We have one of the method called has next. We'll discuss about these cursors in our next videos. So system.out.println iter dot next element will print the next element if it has. Okay. So after 2, we need to print from Java, A, 10, all these things. You see that? Java, A, 10, true, null, ABC, PQ. One by one, we're able to print. Right. So another method contains all. Right. Contains all. So system.out.println, it contains all, and you need to pass what? Another collection. So I am passing collection array list. So it should give me the value true. So it contains another collection. So because of that, we can use contains all. If it is single element, you can just use contains method. You see that contains, but contains all means multiple element, that is collection. So the last value should be true after the PQR. You see that? True. Right. So apart from this, we have seen some specific methods in the linked list to work with stack and queue. So what are those? Add first. Okay. So linked list dot add first. What is that? I can print AAA, something like that. Okay, and I'll try to print it. And now first element should be AAA. You see, AAA. So I can add last element also. Okay, the same way, add last. LL dot add last. I can print ZZZ, some random element, and I'm printing again. So the last value should be triple Z. You see that? Triple Z. And apart from that, what we can do, now I'll remove first. LL dot remove first. Okay. So again printing. Now triple A will not be there, but triple ZB will be there. You see that? Triple Z is there, but triple A I removed. In the same way, I'll remove last. LL dot remove last. And if you try to print now, triple A and triple Z both will not be there. You see that? It came back. All right. So how we have seen here, the same thing here. We removed triple A and triple Z both. Now, so we'll set the get first and get last. Okay. So get first. LL dot get first. And what I'll do, I'll print the get last also. Okay. If I try to print Java, PQR should be there. Right. The first element is Java, last element is PQR. The get first and get last. And any other element methods, remove all. Remove all means LL dot remove all. We can remove the collection AL. So I'll remove the collection. Now I'll print. So PQR ABC should be removed. You see that ABC PQR is not there. The elements which we added in the starting when you created the linked list, the same elements I'm able to see now. Java 8 and true none. Right. This is remove all method. Clear method. Okay. Clear method. LL dot clear. And if you try to print, what happens? Empty linked list will be like this, square brackets. So we'll try to see what happens. You see that? This one. If you try to print the size again, if you try to print the size, LL dot size. Now, no elements inside that. So it has to give me 0. The count is 0. Previously, we have seen 7, right? You see that 0. There is no elements, right? These are all the methods available in linked list. Okay. So we have seen so many methods and the specific methods with respect to added for stack and queues. Okay. So this is all about linked list example, right? So what could be the possible interview questions from here? So what is linked list? What are the different constructors available in linked list? What are the methods available in linked list? Explain linked list with an example, right? So these kind of questions we can face. Okay. So that's all in this video. Thank you. Hi, in this video, we'll talk about vector class in Java. Okay. So where vector comes here. So in the collection tree, so vector comes here under the list interface. Okay. So vector is a class which implements list interface. So the underlying data structure for vector is resizable array or growable array. The same way how array list underlying data structure is resizable array or growable array, same way for vector also same data structure. Here also duplicate elements are allowed. Insertion order is preserved. heterogeneous objects are allowed, and null insertion is possible. So we can add duplicate elements. How, in which order you inserted the elements will be stored in the same order. So you can add different type of elements, and null insertion is possible in vector. So what are the constructors available? So basic constructor vector v is equals to new vector. So it will create an empty vector object with the default initial capacity 10. So when you create, the default initial capacity will be 10. If vector reaches its max capacity, then a new vector object will be created with a new capacity by following which formula? What is that formula? So new capacity is called current capacity into 2, right? So if you talk about this one, so initially what it will do, it will create 10 elements, right? 1, 2, something like that, 10 elements. So the moment it reaches 10, so the current capacity is 10. 10 into 2, 20. So it will create another one with 20 capacity, right? 1, 2, 3, something like that. So 20. So that is the formula here. New capacity is equals to current capacity into 2. Okay. So now, so another constructor. So vector v is equal to new vector, and int initial capacity, you can mention your own capacity, right? So it will create an empty vector object with specified initial capacity. It is an efficient way if you know the capacity. Why? So you when you create normal constructor, basic constructor, it will create the size with 10. So the moment it reaches 10, if you try to insert 11th one, it will create another vector with 20 capacity. If it reaches 20, and if you try to put another 21, then it will create 40. So this is a like time consuming operation. So performance will be decreased. So if you know I'm going to insert 30 elements, 40 elements, 50 elements, 1000 elements, if you mention that, by default it will create with that size. So you can put your all elements in one vector. So no need to do all these operations again and again. Okay. So that is what efficient way means. Okay. So another constructor. So vector v is equal to new vector int initial capacity int incremental capacity also. Previously it is into 2, right? So now you can mention how. So this way, like vector v is equals to new vector. So I mentioned 100 elements initially, and you increment 4. So the moment it reaches 100, and if you try to insert 101, then what it will do, it will create another vector with 100 into 4. So with the size 400, the size, right? Previously, if you did not mention this one, it will be 100 into 2. But if you mention the initial incremental capacity, then with the help of this, it will increment that much size, right? This is another constructor. So it will create an empty vector object with specified initial capacity. And if it reaches its max capacity, then it will increment the vector capacity to the specified incremental capacity instead of double the capacity. Double means into 2, right, by default. So instead of double, it will use that specified incremental capacity. Okay. This is another constructor. One more constructor, very normal, we can add another collection to this vector. So it creates an equivalent vector object for the specified collection object. So for this vector, you can add array list, you can add linked list, right? Something like that. So this constructor will be helpful for interconversion between collection objects, right? So all the methods present in the vector are synchronized. Okay. So multiple threads cannot allow to perform operations on vector. So if it is synchronized, so multiple threads cannot be accessed at the same time. Only one thread can be allowed. So because of that, this is thread safe, and perform vector is defined in java.util package. So vector is best suitable for retrieval operation. So this is not best suited for frequent insertion or delete operation in the middle. Okay. So very similar to array list, right? So methods. So you have add element, add an object to the vector. So this is older version of collection. So because of that, the methods will be a bit different, but you can still use add method, but add is coming from its parent, but add element is its own method. Okay. Instead of add, you can use add element. So remove element. So remove an object from the vector. Remove element at, you can specify some index. Remove an object at specified index. Remove all elements. Remove all the elements. Element at, get the object at specific index. Instead of get method, you can use element at. So other elements is first element, last element. You can get the size of that vector. So what is the capacity? Get the total size of the vector. Okay. So what is the difference between size and capacity? Right. Size and capacity. Here two things are said. You need to talk about size and capacity. So get the count of the elements. Get the total size of the vector. If you say your vector is size is 10. Okay. So inside that I put 1, 2, 3, 3 elements. So this 3 will become size. This 10 is capacity. Capacity means how many elements you can insert. Size means how many elements already inserted. Okay. Enumeration. So get one by one value from the vector. Okay. So this is all about vector. Okay. So the names of the methods will be a bit different. Okay. You have one more extra method called capacity. All right. So this is all about vector. In our next video, we'll see one example by implementing by using all these methods. So what could be the possible entry questions from this? What is vector in Java? So what are the different constructors? We have seen 4 constructors. So what are the different constructors available in Java? So what are the vector methods we have? The methods with a slight difference in the method names. Instead of add elements, instead of remove elements, something like that. Okay. So this is all about vector. Okay, that's all in this video. Thank you. Hi, in this video, we will see vector example. In our previous video, we discussed in detail about vector. So with the help of an example, we'll understand the same thing here. So let me go to Visual Studio Code. So I created one class called vector demo. So if you want to use vector, so I need to import java.util package. So now I can use vector. So now I can create vector v is equals to new vector. Right. So how can I add elements? Right. For this, add elements. So we can use add element of vector v dot add element. So we'll add Java v dot add element. So we can add a character A, as we can add heterogeneous objects. So elements. So we can add integer. We dot add element of true. We dot add element of null. Right. Now I'll try to print system.out.println v. Okay. So let me go to the command prompt and try to execute Java vector demo.java. You see that Java 8, 10, true and null. Right. So with the help of add element, we can add the elements. So with the help of list, so add element using index. So how we can add v dot add of in the 0th index, I will add element called first. Right, and I'll try to print. So I'll try to print. So this method, from where it is coming, this add method with index. So we are getting from its parent interface list. Right. This is its own method add element. This add is coming from its parent. Okay. So this is also possible. We can use that. So now you can see here first. It added first element at the zeroth index. This way also you can add element. So can we add another array? Add array, otherwise add collection, we can say. So I'll take array list. AL is equals to new array list. AL dot add of. We added the same in previous examples also. Add ABC. AL dot add of PQR. Right. And then how we can add multiple elements? Vector dot add all of vector. Now I will try to print. Now at the end of my vector, ABC and PQR should be there after null. So I added, okay, I added vector itself. So I need to add array list, right? So you see that for the vector, I added the same vector also, means another collection we can add. You see, after null, ABC and PQR, right? This is also possible. The same elements you got duplicate elements, that is allowed, right? So that is also no problem. And access elements, right? Get the elements. So v dot get of third element. Now we'll see what is the third element. 0, 1, 2, 3. So third index is 10. Right? We have seen same in our previous examples also, array list, linked list also. With the help of same data, we are creating vector also. You see 10. Right? And now what other elements we can try here? So get the elements. We can get the first element. Okay. Get first element. It will be v dot get first element. Okay. Get first element. What is that? First. It should be first. So v dot get first element. Sorry, first element. That is not get first element. This is first element. Value should be first. You see that? First. And then what other methods? Last element. Get last element. V dot last element. Okay. So it has to print last element, that is PQR. You see that? It is giving me PQR. Right. So now what other last element? So we can replace the element. Replace element. What is that? Set method. So v dot set of in the 0th position, you do with start. Instead of first, do with start and try to print. So what happens? In place of first, I replace it with start. So let me print that. You see that? First start. First replace it with start with the help of set method in the first 0th index. Okay. So that is one thing. Remove elements. Okay. Remove elements. So v dot remove it, and we need to provide the index. This is remove element it. Okay. Remove element at 0th position. All right. So again you print. Now start will not be there. First is replaced with start, right? Now the start will not be there. So it will be start with Java. You see that? Java. Start removed with the help of remove element it. Okay. So this is one of the methods. And then capacity. So v dot capacity. So what is the capacity of this? Okay. So we'll see. What happened? Sorry, there is a typo. So is that 10. 1, 2, 3, 4, 5, 6, 7 elements are there. But the initially how it will be created with the initial capacity 10. So because of that, capacity is 10. But if you try to print the size is 7 only. Okay. V dot size, how much it will give? It will give 7. Right. That is what we have seen in the theory in our previous video. Capacity means how many elements we can insert. Size means how many elements are already inserted. Okay. So that is the difference between capacity and size. So can we use contains method? So v dot contains, we can put what? Java. So it will give me true. So the same thing I'll mention again. So it should give me false. So I'll search, means it contains or not with another element which is not there. So it has to give me true and false, last two values output, you see, true, false. Right. So index of, okay, with the help of index of. So index of the third element, I need to print. So what is that? Most it will be. So what happened? Index of 3. Sorry. Index of 10. The element we need to give, right? The element is at 0, 1, 2 position. So it has to give 2. So if that particular element is not there, it will print -1. If it is there, it will give the index. Otherwise, by default, it will give me -1. Right. So we have seen index of, contains, and whether my vector is empty. V dot is empty. So false. Right. My vector is not empty. We have 7 elements inside that. Right. False. It printed false. Now what we can do that? One by one element. Right. We can print one by one element. Element from the vector. So for that we'll use enumeration. So enumeration is equals to v dot elements, vector dot elements. So you can use the while statement again, while enumeration dot has more elements, okay, has more elements, system dot out dot println enumeration dot next element. These are the methods. Okay, so we'll see how it will print. So enumeration dot, so I missed T, typo, next element. You see that it is printing Java A10 true null ABC PQR. Okay, so now what we can see, another methods, contains all. System dot ordered println v dot contains all of AL. So means you need to give the collection rate. So it has to give me true. The last output should be true. Again, typos. You see that true. Last output is true. So we can use remove all method. Remove all and vector dot removal of, we need to give collection. System.out.println, you just print v. Okay, so now ABC and PQR should be removed from this. What happened? System.out.println v dot remove all. So I did not save the program, so we'll see again. You see that Java 8.10 true null, ABC PQR removed, as we are removing that collection, right? So clear method. So we can directly use clear, otherwise v dot remove all elements. Okay, and then try to print the same thing. What you'll get? Empty vector, right? Empty vector, like this. If you try to print the size again, v dot size, so obviously you should get 0. Okay, so we have seen all these methods. So let me execute this also. It should give me 0, right? 0. So this is how we can work with vector, all the methods available in vector. Okay, this is one of the basic example demonstrating all the elements inside the vector. So what could be the possible interview questions from this? So sorry, what is vector in Java? What are the different constructors available in vector? What are the methods available in vector? So I copy pasted a previous slide, so because of that we have seen linked list. But what is vector in Java? Different constructors and different methods. Okay, so that's all in this video. Thank you. Hi, in this video we'll talk about stack in Java. So where it comes in the collection tree. So under the list you will see the stack. Stack comes under vector. So this is comes under vector class. So the child class of vector. So comes under list interface. Okay. So stack is the child class of vector. Okay. So it is specially designed for last in first out order. It is for LIFO order. Last in first out order. Specially designed for. So duplicate elements are allowed. Insertion order is preserved. So the how you insert the elements, it will be in the same order. Heterogeneous objects are allowed. You can insert different type of data types into this stack. Null insertion is possible. Okay. What are the basic constructors? Stack S is equals to new stack. Elements are added to the top of the stack and removed from the top of the stack. Okay. Right. So since stack extends the vector class, it inherits all the methods of vector. Okay. So how it will be? So if you see, stack will be like this. So how the elements will be added to this? So if it is stack, right? Something like this. So the first element here, the next here element will be here. So if you try to get the element, so the last element you need to get the first, right? So because of that, LIFO last in first out. Okay. So added at the top, right? Top of the stack, remove from the top of the stack. So you add in the top means top of A is B, top of B is C. So from the top only you can remove. So it extends vector class all the methods. So we already saw what are the methods available in detail in our previous video. So you can watch that video for all the methods, right? So the same thing will be applicable for stack also, right? So now let me clear this. How the index will be? You see that index will be like the first element is 0th index, second element is first index, third element is index, but you have something else called offset. So offset will be like this: the last element is 1, the next element is 2, and the next element is 3. So here we have only 3 elements. C will be the first element, B will be the second offset, and for the element A is offset 3. Okay, you need to remember this. So the methods available. So object to push, to insert an object into the stack, right? With the help of push method, you can insert. Pop, to remove and return top of the stack. Okay, so that is called pop. And peek, to return top of the stack without removal. So that is not the top element. Okay, so top element, return top element. Okay, that means last element. So top element, here also element. Okay, so boolean empty returns true if stack is empty. Int search, so returns offset if the element is available, otherwise returns -1. Right, so we have seen that -1 in the previous examples also, vector also. If the element is not available, then it will return -1. Okay, push, pop, peek, empty, search. Right, these are the different methods available in this stack. So we'll see these methods with the help of one example. So let me go to Visual Studio Code. Right, I have created one class called stack demo. So to work with stack, I need to import java.util package. So I need to create an stack is equals to new stack. I had to create an object. So how we can add elements? Right, yes dot add. Sorry, you can use push, right? What is that? Java is that push the same elements what we are using with previous examples. We'll use the same elements. Push 10. Sorry. Yes, dot push of true. Yes, dot push of null. Right. Then we can see duplicates are allowed, right? So we can see that one also. So system dot out dot println. Yes. Okay. So we'll try to execute this first and see what is the output. Java stack demo.java. Whether push is working or fine. You see that push working. Java A 10 true null, again 10 means duplicate elements allowed. Right. So perfectly push is working. So then I want to remove an element. Remove an element. So yes dot pop. Okay, is dot pop, and you can say system dot out dot println. Yes. Let me copy this. Now you can see s dot pop, it removes an element. What is that element? The last element's first, right? So it removed 10. Okay, it removed 10. And if you want to get an element, okay, you want to get an element, yes dot peek. Right. So it will print null. You see that last value is null, right? Last value is null. So we already saw something like this. Give me 1 second. So here Java will be, and then E, and then 10, and then true, and then null, right? So it will interact with the top element. Because of that, I'm getting null here, and because of that, it removed 10. It will be on the top of 10, right? It got removed, right? After that, what is that element? Null, right? Because of that, it is printing null. Okay, so let me clear this, and then peak. So we can check whether my stack is empty or not. Empty or not. Control V, yes dot empty. Simply empty, right? So definitely it will give me false. The reason is it is not empty. Right, false. Right. So then search operation. Right, search. So yes dot search of, I'll take A. Sorry, A. And the same way, I'll put another one, yes dot search of Python. So if it is there, I'll get the what? Offset. What is that offset? So here I'll get -1, right? So offset will see and go and execute. Is that 4? The reason is 1, 2, 3, 4, right from the top. So A will be at the 4th offset. So if it is not there, -1, right? So this is how all the methods available in stack we can see. Right. Apart from that, we can use all the methods which we used for vector. Right, vector is stack is child of vector. So because of that, we can use all the methods from the vector. Apart from that, push, pop, search, peek, all these from very specific to stack. So because of that, we have seen these methods. If you want to work with those, you can see the vector example. Okay. So what would be the possible interview questions from here? What is stack in Java? What are the different constructs available in stack? What are the stack methods? So pop, push, peek, search, empty. So all these methods from the stack. Okay. So that's all in this video. Thank you. Hi, in this video, we'll talk about enumeration in Java. So this is one of the cursors in Java. So if you talk about enumeration, so first, cursors are used to get the elements one by one from the collection, right? So enumeration is one of the cursors. So then obviously, so enumeration is get elements one by one from the collection, right? With the help of enumeration, we can get the elements one by one from collection. So the method is public enumeration elements. So these elements will give me the return type is enumeration, right? So one example is vector is equals to new vector. So if you want to get all the elements from the vector, so vector dot elements. So vector dot elements means it will give me the what kind of information? Enumeration. Return type of elements is enumeration. So I can save in enumeration object. Okay. So what are the methods available in enumeration? Public boolean has more elements. So in one of our previous videos, we have seen that has more elements. To verify elements available in the collection, has more elements will verify that any element is available in the collection or not. If it is there, it will return true, otherwise false. So public object next element, to get the next element if it has next element. So if you have any element in the collection, then if you want to get that element, you need to use next element method. So what are the limitations with enumeration? Okay, so enumeration is applicable for only legacy classes. Okay, so vector, stack, something like that. And with the help of enumeration, we can perform only read operation. So we can only get the information from the collection. Okay, so it works only in the forward direction. So only in the one way it will work. Right. So only next element, next element, next element, right? We are saying only one method, that is next element. If it has more elements, on the next element method is available. With the help of that, only forward direction, we can get the elements, right? So with the help of one example, we will see. So this is enumeration demo. If you want to work with enumeration, so import java.util.star, right? So first we need to get any collection, right? So once you have any collection, then only you can apply that enumeration to get the elements from that collection. So I'll take vector v is equals to new vector. Okay. So I want to add elements to this. So with the help of one for loop, I will add elements. Int I is equals to 1, I less than or equals to 10, I plus plus. So now v dot add element of I, right? So it will loop through 10 times. So each time, first time I is equals to 1, it will add 1. Second time 2 will add 2 until it reaches 10, right? 1 to 10, it will add. So if you want to verify that, system.out.println, we just print v. So it has to print 1 to 10, right? Let me clear this. Java enumeration demo.java. So what happened? Sorry, java.util. Okay. You see that 1, 2, 3, 4, 5, 6, 7, 8, 10. So I added 10 elements. Okay. So now I need to print one by one these elements. So for that, enumeration E is equals to v dot, what is that? Elements. Okay, with the help of this, we can get all the elements to my enumeration. And while E has more elements, if it has more elements, print, sorry, we need to print those elements. Okay, what is that? E dot next element. Okay, next element I need to print. Now if I go here and run the same thing, now you can see one by one element. You see that first 1, 2, 3, 4, 5, 6, 7, 8, 10, right? So now you can perform something in the while loop. Okay, so not only getting the elements, if I want to perform something on that, so what I can do, once I get that all are in objects, right? It will written in the form of objects. So I want to, next element will give me, what is that? So if you go back, so next element will give me in the form of object, return type is object, but my elements are integer. So I need to convert from object to integer. For that, what I'll do is integer I is equals to, I need to typecast. Okay, so integer E dot next element. Okay, I'm getting the next element, and if I am performing some I percentile 2 equal to 0, if I percent equal to 0, then only I need to, what I need to do, I need to print that I value. I need to print that I value. Okay, so what happens? 1 percentile 2 is not equal to 0, 2 percentile 2 0. So it will print from all even numbers, 2, 4, 6, 8, 10, right? So let me execute this. You see that 2, 4, 6, 8, 10. It is printing all even numbers, right? So if I want to perform something else, I plus 1, right? Just an example. So let me copy paste this again. So I don't want to do all these things. once I get the integer value in the form of integer, I need to perform I plus 1. Now what it will do, it will print from 1 plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, comma 11. Right, it will give 2 to 11. The reason is once I get that element, I'm adding 1 to that. First time 1 plus 1, 2. Second time 2 plus 1, 3, something like that. So if you try to execute the same thing, you see that 2 to 11 it will print. But once you get, you can perform some operation on that. So and here you have only option to get the element. With the help of next element method, you can only get the element. That is one of the limitations to what is that enumeration. Right. So after that, after I perform on this, if I try to print the enumeration again, okay, if I try to perform enumeration again, what happens? Nothing happens. You can get the same output in the starting and the ending. The reason is we can only get the elements. We cannot do any other operations to this vector or collection. So because of that, after performing so many things, we'll get the same vector again. Okay. So this is all about enumeration. So what could be the possible interview questions from this? What is cursor in Java? What is enumeration in Java? Methods available in enumeration in Java. So limitations of enumeration. So you can perform only read operation. Okay. So that's all in this video. Thank you. Hi. In this video, we'll talk about iterator in Java. So iterator is one of the cursors in Java. So when you talk about iterator, so first, what is cursor? Cursors are used to get the elements one by one from the collection. So iterator is also to get the elements one by one from any collection. Okay. So with the help of iterator, we can perform read and remove operations. So in our previous video, we have seen that enumeration, with the help of enumeration, you can do only one operation, that is read. But here we can do read and remove both operations with the help of iterator. So the method is public iterator. Iterator is a method. The return type of that is iterator. Okay. So if you take an example, array list is equal to new array list. So array list dot iterator will give me iterator instance. Okay, reference. And then what are the methods available in this? So public boolean has next to verify elements available in the collection. Public object next to get the next element if it has next element. So in our previous video, we have seen that has more elements, has a next element. So bit lengthy names, but here simply has next. Only two these two name what do you say, like simple names, so short names. So apart from that, public void remove to remove the element from the collection. So that is what extra method in iterator, right? So still we have limitations here. So with the help of iterator can perform only read and remove operations, and it works only in the forward direction. This is also with the only forward direction. The reason is we have next method only. We can get the next element only. Okay. So we will see all these things with the help of one example. So let me go to Visual Studio Code. Here I have created iterator demo. So first I'll import java.util.star package. So here I'll create array list. AL is equals to new array list. So I need to add elements for this. So I'll use for loop int I is equals to 1, I less than or equals to 10, I plus plus. So then AL dot add of I. So it will add all the 1 to 10 elements to this array list. So let me print this one. System.out. Print ln array list. Okay. So if I try to execute this iterator demo, you see that it is printing 1 to 10, right? So now I want to print one by one. How you can do that? So al dot iterator method. So what it will give me back if the return type is iterator, iter is equals to al dot iterator. Now you can use while loop. While iter has next. Okay, if it has next, then what you can do? You can print system dot out dot print ln. What I need to do? Iter dot next element. So you can print only next element because of that. This is forward direction. Okay, only one way, one direction, single direction cursor. Okay, so now if I try to execute, it will print 1 to 10 one by one, right? So with the help of iterator, that is the advantage. So if I want to perform something else on this, okay, same thing what we have seen in our previous enumeration. Let me copy paste this instead of removing. So the moment when I get next element, that will be in the form of what? Object, right? So that will be in the form of, so I need to convert into integer. Integer I is equals to, so I'll typecast integer iter dot next element. So the next element will be in the form of object. So because of that, I'm converting into what? Integer. So I percentage is equals to 0. So if it is, then only I need to print. Okay, what is that value? I need to print I value. So it will be print only even numbers, right? It will print only even numbers. So let me go to here, execute. Is that 2, 4, 6, 8, 10? The reason is if it is the remainder is 0, then only you can print it. Okay. So 2% L2 equal to 0. So 4% 2 equal to 0. Then print something like that. So, and if I want to remove, all right, we can remove the elements, right? So we can remove the elements. So for that also, let me take this one. Let me take this one. Let me comment this and I'll copy paste again. So has next integer. If I percentile 2 equals to 0, then what I'll do, iter dot remove. So if it is I percentile 2 equal to 0, then remove means I am removing even numbers and the remaining numbers you print. So here it will print odd numbers, right? So let me go here and execute. You see that this time 1, 3, 5, 7, 9. But okay, after completion of this, I need to print system dot out dot print ln. What is that? AL, array list, right? So if you try to print this now, you see the difference. You see in the top, when you added, it added 1 to 10. So, but what I did in meanwhile, I removed some elements from this array list. If it is even number, I removed. So after that, if I print again, you see that what it is giving me 1, 3, 5, 7, 9. So whatever we have in that. So we can perform what operations? Read and remove operation. Remove operations we perform. So after performing remove operation, if you see here, only the remaining elements. So only odd numbers it is giving me. So that is extra thing we can do with the iterator that is not available in the enumeration. Okay. So this is all about iterator. So what could be the possible interview questions from here? So what is cursor in Java? What is iterator in Java? Methods available in iterator and limitations of iterator. What are the limitations? Only we can perform read and remove operation. And one more thing is only forward direction. Okay. So that's all about iterator. Thank you. Hi, in this video, we'll talk about list iterator in Java. So list iterator is one of the cursors. So then what is list iterator? So first, cursors are used to get the elements one by one from the collection. Okay. So then, list iterator is to get the elements one by one from the collection. Then with the help of list iterator, we can perform add, read, replace, and remove operations. So in the enumeration, we can do only read operation. With the help of iterator, we can do read and remove, but here we can add, replace, apart from read, remove. Okay. And it works in both the direction, that is bi-direction. So enumeration iterator is in single direction, that is forward direction. Here both the direction, forward and backward. So method is list iterator. The return type is list iterator. So list iterator L iter is equal to list dot list iterator. Okay. So here the list means any list object. Okay. It works only with the list object, means array list, linked list, all these things. Okay. So not for all the collections. So methods. So has next, we have seen to verify elements available in the collection. Next method will to get the next element. Next index to get the index of the next element. Has previous. How we have has next. The same way we have has previous. The reason is it is bidirectional. We already discussed it, right? So we can go backward direction also to verify previous elements available in the collection. So we can get the previous element. How we have next element to get the next element. We have. So here we need to give previous element. There is a typo. To get the previous element, if it has previous element, not next element. Okay. And previous index to get the index of the previous element. To remove the element from the collection. The set to replace the element. Right. Add to add the new element. So we can see all these methods with the help of one example. Okay. So let me go to Visual Studio Code. And we have created one list iterator demo. So to work with these things, I need to import java.util.star package. So now here I'll take one of the things, a list called linked list. Linked list LL is equals to new linked list. And I need to add some elements to this. So LL dot add of, I will add apple. Okay. LL dot add of banana. So LL dot add of, what is that? Tomato. So LL of added cow. Add of papaya. Add of something like green mango. So some random elements I added to this. So let me print first system.out.println LL linked list. Okay. Let me print this first. List iterator demo.java. Is that apple, banana, tomato, cow, papaya, green mango. Right. So I want to print one by one. That is the purpose of list iterator, right? So list iterator L iter is equals to LL dot, right? List iterator. Right. Now you can use while L iter dot has next. Okay. If it is has next, then system.out.println. So L iter dot next. Right. These are very simple and we already saw so many times in our previous videos. So now we just execute and see prints one by one or not. System.out.typo println. Okay. So now it will print one by one. So apple, banana, tomato, cow, papaya, green mango. So this is common. But now what I want to do, I want to perform different operations using with methods available in the list iterator. So let me copy paste here. Has next. So everything is string, right? So string s is equals to, I need to typecast. The reason is iter dot has next will give me object. Right. This will give me the return type is object. So I need to convert to string. So I converted to string. That's fine. Now, what I need to do, I need to perform some operations on this. If s dot equals, if s dot equals, if s is equals to cow, okay. If s is equals to cow, I need to remove that. Iter dot remove. We have that option, right? And if s dot equals, what is that? If it is tomato, iter dot set to watermelon. Right, if it is tomato, replace that with watermelon. So we can do replace operation, right? That is what I'm doing. If s dot equals green mango, right? If you have green mango, go ahead and add yellow mango, something like that. Okay. Anything can be performed here, right? So we can remove, we can add, we can replace, right? So we did all these things. So after that, I will print the linked list again. So this is the linked list. I will print that. Okay. So what we did, we can read access. Anyhow, we are reading with the help of next element, right? So apart from that, if it is cow, you just remove that. If it is tomato, replace with watermelon. If it is green mango, add yellow mango. Something like that we can perform, remove, replace, add, and next means read, right? So if you try to execute this, you can see the difference. You see that apple, banana, banana, tomato will be replaced, right? What happened here? So what I did here, okay, typo again, typo, because tomato means, so because of that, you see that apple, previously there is an apple, banana, but the moment when it's tomato, that is replaced with watermelon. Okay, when you found cow, it is removed. Papaya. When you find green mango, add yellow mango. So because of that, we have green mango, yellow mango both. So we can perform some these kind of operations, right? So apart from that, previous element, next element also we can get, right? So what I can do here, while iter what are the methods available here? Has previous, okay, has previous. Then I want to print system.out.println iter dot previous. Whether it will print anything or not, we'll see. Okay. So has previous is a method. Mouse is not working. So has previous, we forgot to give the method with the brackets. So now while L iter that has previous, if it is previous element is there, I need to print the previous elements. Okay. So I'll go back and I'll try to execute the same thing. Java list iterator demo.java. You see that it is giving me in the reverse order. So has previous means it will see from this end. So yes, previous element is there, this one, previous element is there, this one, until it reaches the first element. So this is how the bidirectional we can go, right? So anything else we can see here. So this is previous index, next index. So if you get that, try to get the next index. System.out.println next index. We'll see what exactly it will give me. That's 0. So after this, we do not have any element, right? So because of that, it is giving me 0. So if I try to give the previous index, so previous index is -1. After, before 0, there is -1, right? So if you want to see better these things, so instead of here, you put here. You see that 0, 1, 2, 3, 4, 5. But it is work after the previous element. What is the previous index? So previous index is 4. After green mango, what is the previous index? 3. So something like that. After you reach this point apple, before that we have -1. So this is how you can use previous index and next index. If you're talking about the L-iter.next, then you can print the next index. Instead of seeing outside, if you put here, you will get the exact information. Okay. So we have seen all the methods available in the list iterator. Okay. So how many methods are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. Total 9 methods are available here. Okay. So what could be the possible interview questions from here? So still we have some limitations here. So it is applicable for only list objects. So we already discussed this is linked list, array list, all these things only. It is applicable. It is not for all the collections. Okay. That is, we can perform read, update, remove, replace all these things, but it is applicable only for list objects. And what could be the possible interview questions? What is cursor in Java? What is list iterator in Java? Methods available in list iterator? What is the limitation of list iterator? And advantages of list iterator in Java. Okay. So that's all in this video. Thank you. Hi, in this video, we will see the difference between enumeration iterator and a list iterator. So we have seen all these things in detail as a separate videos in our previous videos. So now we'll see the only differences between these three. Okay. So enumeration iterator and list iterator. So what is the difference between these three? Okay. So all are cursors, right? We know these are all cursors in Java. So enumeration, it is applicable for only legacy classes. Okay, but iterator is applicable for any collection object. Okay, any. But iterator is only for list object. Okay, so in these three, enumeration is only for legacy Iterator is for any collection object, and list iterator is for only list objects. So this is forward direction, this is forward direction, but list iterator is both the directions forward and backward direction. Okay, so we'll get elements by elements method, right? Vector dot elements we have seen. So here we'll get with the help of iterator method. In the list iterator, we'll use list iterator method. So we'll get the elements by here, list iterator in the list iterator, iterator in the iterator, elements in the enumeration. So with the help of enumeration, we can do only read operation. Okay, but in the iterator, we can perform read and remove operation. Right. In the list iterator, we can perform read, replace, add, remove. 4 operations you can perform. 2 operations perform. Only 1 operation we can perform here. Okay. So here 2 methods available to perform operation. So has more elements, has next element. Right. Here 3 methods. Next element, next, and remove. Here 9 methods are available. For that remove, sorry, previous, right, previous index, next index, next elements, previous elements. So we have 9 methods here. We have only 3 methods, here only 2 methods. So enumeration is introduced in Java 1.0 version, and cursor and iterator and list iterator both came in 1.2 version. So these are all the differences between enumeration, iterator, and list iterator. We have seen 1, 2, 3, 4, 5, 6 differences we have seen. Okay. So these are all differences between these 3 cursors: enumeration, iterator, and list iterator. Okay. So let me clear this. So what could be the possible interview questions from this? Right. So what is cursor in Java? So what is the difference between these 3 cursors: enumeration and iterator and list iterator? Okay. So that's all in this video. Thank you. Hi, in this video, we'll talk about set in Java collections. So set comes under here, under the collection. So set is the child interface of collection. If you go back, you see that this set is child of this collection interface. So it is used to represent a group of individual objects as a single entity, where you need to remember these 2 points. Duplicates are not allowed and insertion order is not preserved. Okay, so this is the difference between list and set. So in the list, we can insert duplicate values, and the insertion order is preserved, means in which order you store, it will be stored in the same order. But coming to the set, here set will not allow duplicate values and insertion order is not preserved. So the way how you stored or inserted the values, it will not be stored in the same order. Okay, so that is the difference between these 2, and this is all about set. And a set doesn't have any new methods. So set doesn't have any methods by itself. So we need to use its parent interface methods. So those are collection interface. Whatever the methods inside the collection interface, it will use in set. Okay, what are the collection interface methods? So Boolean add all, Boolean remove all, Boolean retain all, void clear. Okay, and Boolean contains all, is empty, size, to array, iterator. So these are all the methods which are available in the collection. So set will use all these methods. Okay, so it doesn't have its own methods. So it will depend upon its parent interface called collection. Whatever methods available in the collection, we can use all these methods inside the set. Okay, so that is all about set. So what could be the possible interview questions here? So what is set in Java? So group of individual objects, and it will not allow any duplicate values, and the insertion order is not preserved. That is what we need to mention. What are all the methods defined in the set? So personally, set will not have any methods. So it will depend upon its parent interface called collection. So the methods which also we can explain those. Okay, so that's all in this video. Thank you. Hi, in this video, we will talk about hash set in Java collection. So what is hash set? So if you see the collection tree, you see that in the top you have collection interface, under that we have set, under that we have hash set. So we are talking about this hash set. So hash set is a class which implements set interface. Okay, hash set is a class which implements set interface. So we already saw that comes under set interface. The underlying data structure for hash set is hash table. Duplicate elements are not allowed. So in our previous video, we already discussed about set interface. So set will not allow duplicate values. So hash set will not allow duplicate elements. If try to add duplicate elements, will not get any compile time or runtime errors. So it will not allow duplicate elements. But if you try to add any duplicate element, so you will not get any error or exception. Okay. So, but it will not get added to the hash set. That's it. So we will see with the example. Add method simply returns false. So if you try to add, then if you try to print, it will return false. But more than that, it will not give you any exceptions or errors. Okay. So insertion order is not preserved. So this is also one of the important points when you talk about set. Insertion order is not preserved. The way you inserted, it will not be in the same order in the hash set. Elements will be inserted on the basis of hash values. So in the same order it will not store, but what order it will store, it will be based on their hash values. Heterogeneous objects are allowed. So we can add different type of elements to the hash set. We can add boolean, we can add integer, we can add string, all this combination you can add it to the hash set. Null insertion is possible. So we can add null value also. Hash set is best suitable for search operation as elements stored on the basis of hash values. So because of this feature, the search operation is efficient on hash set. If you try to do your frequent operation is search, then preferred set is hash set. Okay. So preferred collection is hash set. So what are all the constructors available for hash set? So hash set is called new hash set. Okay. So this is the first constructor. So when you talk about the points, so it will create an empty hash set object with default initial capacity 16 and default fill ratio 0.75. Okay. So what it means? So the moment when you create hash set, so it will create hash set. The default capacity is 16. 1, 2, 3, something like that. 16. Okay. But when it will create a new hash set, right? So the moment it fills 75% means 0.75 means 75% is filled. Then it will create another hash set. Okay. But in the list, once it completes fully 100%, then if you try to insert a new value, then it will create new list. But in the set, in the hash set, it arrives at the 75%. It fills 70% of the elements, then it will create the new hash set. Okay. So if hash set reaches 75%, the new hash set object creates with default fill ratio. Right. So again, it will create another hash set, and there also the default fill ratio is 75%. Okay. This is one constructor. The another one is hash set int initial capacity. Hash set is called new hash set int initial capacity. Means, so by default it will be what? It is 16. Right. By default, if you did not mention this value, it is 16. But you know that you are going to store 100 values. You are going to store 200 values, otherwise 1000 values. right? If you know, prior information, if you have prior information that how many values you are going to store, then you can directly use hash set h is equals to new hash set of 1000. Okay, so this is how you can create an hash set. This is another constructor, right? So it is an efficient way if we know the capacity, right? So it means normally it will, if it fills 75%, then it will create another one. Then 75%, it will create another one. So it's a tedious job, right? Performance will be decreased. So if you know how many elements you are going to store, then use this constructor. Then it is an efficient way to create the hash set. Even though for this also, like if you put 1000, then if it reaches 75%, it will create another one. That is common. Okay. So another constructor right here, initial capacity and fill ratio, right? Default initial capacity is 16 and fill ratio is 75%. So you can override these two things. Okay. It will create an empty hash set object with specified initial capacity, might be some 1000, but I want to create a new hash set not after filling the 75%, 95%. Okay, once it fills 95%, then you create the new hash set. Otherwise 98%. So it's your own fill ratio. You can decide that. Okay. So another constructor is very common, like you will pass the collection object to this hash set. Okay. So it creates an equivalent hash set object for the specified collection object. This constructor will be helpful for interconversion between collection objects. If you mention list here, so equivalent hash set will be created. Okay. So that's how it will work. These are all the constructors available in the hash set. So now we'll try to write an example and see how it works, how we can create and how it works. We will see with the help of an example. So let me go to Visual Studio Code. So I created hash set demo. So we'll use some methods and see what operations we can perform. So hash set hs is equals to new hash set. To work with hash set, I need to import java.util.star, right? So after creating a set, I want to add elements, right? hs.add of java, hs.add of character a. So we are adding heterogeneous objects, one string, one character, one integer, 10. hs.add of true, hs.add of null. Okay, so we added different values. System.out.println hs. So here we need to remember one thing: insertion order is not preserved, right? So we'll try to execute this and see how it will be. Java hash set demo.java. You see that the order we inserted Java a 10 true null, but here null a Java 10 true. So it's a different order. So insertion order is not preserved. On the basis of hash values, it will store. It will insert the values. Okay, this is we need to remember. So another one important point. This is one of the important points. Another one: add duplicate values. It will not allow. Right? It will not allow. So I try to add hs dot add of 10 again. Okay. So let me try to execute. You see that only 110. The 10 which I added duplicate values, it will not allow. And we already discussed, if you try to add duplicate elements, nothing will happen, no errors, nothing. It will just not allow. It will not just add that. So it will not add that. Okay. So, but how you will make sure that it added or not? Means how it behaved internally. Okay. So what I'll do, I will put hs.add of 10. Okay. So it's simply written false. So if it added, it will return true. If it did not add, it will return false. So we'll try to execute. You see that false. And if you try to print again, the same thing. So if you try to add duplicate values, nothing will happen. Okay. So it will return false. This is also we need to remember. So I want to add multiple elements. So I'll take array list. AL is equals to new array list. And I'll try to add some values to this. AL dot add of ABC. AL dot add of PQR. Okay. So now what I need to do, I need to add hs dot add all of AL. Okay. If I try to print this one, right, it will add those two elements, but the order will not be preserved. You see that PQR first, ABC in the middle, right? PQR in the second value. So if it is a list, it will be added at the end of this list, but it is set, so it will not be the same order which we inserted. Okay, that we need to remember. So if you try to print the size, so hs dot size, you see that 7 values. Okay, so 1, 2, 3, 4, 5, 6, 7. Right, we have printed the size. Okay, now we'll remove hs dot remove. I'll remove the null value and I'll try to print again. So this time it should not show the null value in the set. You see that it started from the PQR. So null removed. Right. So now, sorry, access the elements or objects one by one. So we can use iterator itr is equals to hs dot iterator. So while iterator has next value, you just print that value. Iter dot next means iterator object dot reference dot next. Okay, so we'll try to execute this. You see that one by one PQR, A, Java, ABC, 10, 2. Right. So this is how we can print one by one value using iterator. This is one of the cursors we already discussed, right? So this is the same thing. Okay, this is how you can use a hash set. The important point you need to remember is insertion order is not preserved. Duplicate values will not allowed. Okay, and if you try to insert the duplicate values, nothing will happen. No harm to your program. So it will just return the false, but no exception, no errors will occur. Okay. So what could be the possible interview questions from here? So what is hash set in Java? What are the different constructors available in hash set? Right, we have seen 4 different constructors. Okay, so that's all in this video. Thank you. Hi, in this video, we'll talk about linked hash set in Java collections. Okay, so what is linked hash set? So if you see the collection tree, under the set, we have hash set. Under the hash set, we have linked hash set. Okay, so we are talking about this linked hash set in this video. So linked hash set is a child class of hash set. So that is what we have seen, right? This is child of hash set. So linked hash set is a child class of hash set. It is very similar to hash set except the following differences. So it is very similar to hash set, but there are few differences. What are those? So the underlying data structure is a combination of linked list and hash table. Okay. So the underlying data structure of linked hash set is combination of linked list and hash table. Insertion order is preserved. Normally, if you talk about the set, if somebody asks what is set, the first point what we'll say, insertion order is not preserved. But there is an exception in linked hash set, that is insertion order is preserved. So remaining things are same. Okay. So we'll try to see everything by taking an example. So let me go to Visual Studio Code. So what is that? I created one second. I created one of the classes called linked hash set demo. Okay. So how we can use this? Linked hash set LHS is equals to new linked hash set. To use linked hash set, so we need to import java.util.star. All the collections we need to import java.util.star. So I need to add the elements, right? So LHS dot add of, so Java LHS dot add of A dot add of 10. So LHS dot add of true, LHS dot add of null. Okay. Now I'll try to print the system dot out dot println and this linked hash set. So we'll see what happens. Okay. So insertion order should be preserved, right? Should be preserved. That is what the exception we have seen. So let me go to command prompt. Let me execute this. You see that? Java A 10 true null. In which order we added the elements, in the same order I can see here. So it proves that insertion order is preserved, right? So that is what the exception in the linked hash set. So add duplicate elements. Right. So LHS dot add of 10. And if you try to print this, and try to execute this, you see that the same output after adding 10 means it is not allowing duplicate values, right? Add duplicate elements, it will not allow, right? So how will make sure that LHS dot add of 10? So it should return false. If it adds, it will return true. Otherwise, it will return false. You see that? False. So it will not add the duplicate values. So can we add multiple elements using array list? So A is equal to new. So we already saw the same examples in our previous collections also, but I'm taking the same examples to demonstrate. So LHS dot add of ABC, and here LHS dot add of PQR. And how I can add this one? LHS dot add all of AL. And just try to print the same thing. Okay. So this should add at the end of your already created linked hash set. Right. The reason is insertion order is preserved. You see that at the end ABC PQR. Right. So we can add multiple values. So what else we can see? Size. Okay. We'll see the size. So how many elements are there inside the linked hash set? There are 7 elements. Okay. So can we remove that? Anything? We'll use the remove. LHS dot remove of. I'll remove the null value. And then I'll try to print. Okay. So this time I should not see null value. You see that there is no null in this linked hash set after removing the element. So another is to access elements one by one. So the same thing, I'll take iterator. ITER is equals to new iterator. Sorry, LHS dot iterator. Okay. Then while ITER dot has next. So then we need to print system dot order println iter dot next element. Okay, that's all. So we'll try to execute and see whether it is giving the output one by one. You see that Java A10 true ABC PQ. So we are able to print one by one. So the same thing, the same example we have seen in our hash set also, in our previous video hash set also, but only the difference is insertion order is preserved. That is the only difference we saw in this example. Okay, this is all about linked hash set, and underlying data structure is what? Combination of linked list and hash table. Okay, so what could be the possible interview questions? What is linked hash set in Java? Difference between hash set and linked hash set. Okay, so that's all in this video. Thank you. Hi, in this video, we'll talk about sorted set. So this is an interface. So we'll talk about sorted set in Java collections. So in this tree, so under the collection you have set, under the set we have sorted set. This is an interface. Okay. So we are talking about this sorted set in this video. So sorted set is a child interface of set. Right, that's we just saw. If we want to represent a group of individual objects without duplicates, and all objects will be inserted according to some sorting order, then we should go for sorted set. So whatever it is, group of individual objects means every collection is group of elements, right? So it represents a group of individual objects without duplicates, right? Set will not allow duplicate values. And the insertion means the how you insert the values, inserted according to some sorting order, right? Then we should go for sorted set. The sorting order can be either default natural sorting or customized sorting order, any one of these two. So the sorting order will be in the default natural sorting or customized sorting order. So alphabetical order is the default natural sorting order for string objects. String means words, right? So if it is words, alphabetical order will be the default natural sorting. Ascending order is the default natural sorting order for numbers. So if you store numbers, then the default natural sorting is ascending order. Okay. So what are the methods available in this? So object first, it returns the first element. Object last returns the last element. Sorted set and the method name is headset. The return type is sorted set itself. Okay. So object O returns sorted set whose elements are less than specified object. So the object which you mention here, less than that object, the previous elements it will give you. So the same way, tail set return sorted set whose elements are greater than or equal to specified object. Means the object which you mention, that object and right side of this objects. Okay, so that it will give. So we have subset, means between these two, object 1 and object 2. So after object 1 means object 1, and after object 1 till object 2 means less than object 2. Object 2 will not come, but object 1 will come. Object 1 to object 2 minus 1. These values it will give me as a subset, and that is also sorted set. Okay. Comparator. So comparator with what comparator will do? Returns comparator object that describes underlying sorting technique. And what is that? It will return null if you use default natural sorting order. So my set is already sorted with this default natural sorting order, then it will give me null value. Okay. So if you take one example, like this is my sorted set, I stored value something like this. Give me 1 second. So if it is sorted set and the value something like this, 100, 101, 102, 105, 110, 121, 150, 200, 205, 250. Right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So total I have 10 elements in this. Okay. 10 elements I have in this sorted set, and everything is sorted, right? 100 is starting and 250, and this is natural sorting order. Natural sorting order. The reason is these are all numbers, right? So these are all numbers because of natural sorting order, ascending order. So from low to high, ascending order, right? This is my sorting order. Then this is my sorted set. Okay. Then if you try to use the methods which are there. Okay. First method. First means it will print the first value. Last means it will give me the last value. 100, 250. Headset 105. So headset 105 means what we discussed. So in our previous slide, what we discussed. 1 second. So here, return sorted set whose elements are less than specified object. Right, less than specified object means the left values. Okay. So if that is the case, you see here, headset is 105 means previous 100, 101, 102. It will give me 100, 101, 102, less than this 105, these values. Okay. And this is also sorted set. Right, all the values in the sorting order. Again, ascending order. Right. So tail set of 150. 150 means what is that? That value and the remaining values. Right. So 150, 200, 205, 215. 4 elements. So this will, it will give you. You see that 150 to 215. And again, this is also sorted set. You see that ascending order 150, 200, 205, 250. This is tail set. Subset. Subset means that value less than 1. This is means this value minus 1. So here it starts here 121, 150, 200, and 205 will not come. You see that 121 to 200. And this is also sorted set. Right. So is headset, tail set, subset. And comparator. Comparator, what we saw, if it is default natural sorting order, right, then the value will be null for numbers. Not only numbers, if it is strings also, but if it is default sorting order, then it will give me null value. Right. So, but we cannot write any example for this. The reason is this is interface. Right. Sorted set is an interface. So we can use its implemented class. Right. So we need to use any one of the implemented classes. Right. If you want to see an example. So that we will see in our upcoming videos. Okay. But in the sorted set, we need to remember these points. Right. So what could be the possible interview questions from here? What is sorted set in Java? The methods available in sorted set. Okay. So that's all in this video. Thank you. Hi, in this video, we will talk about tree set in collections. So what is tree set? So tree set comes under this, in this here, under the set interface, sorted set, navigable set, and then tree set. So we'll talk about this tree set in this video. So what is tree set? So tree set is a class which implements navigable set interface. So that is what we have seen here. You see navigable set is an interface. So this comes under this one. This implements navigable set. The underlying data structure for tree set is balanced tree. Okay. The underlying data structure for tree set is balanced tree. Here, duplicate elements are not allowed. Insertion order is not preserved. Heterogeneous objects are not allowed. So in entire collections, tree set and tree map, I think in these both areas, we cannot add heterogeneous objects. Okay. So these will not allow heterogeneous objects. So why it will not allow heterogeneous objects? We will see. So null insertion is possible with some conditions. What are those conditions? We will see. Null insertion is possible, but with some conditions. So what are the constructors? So tree set is equals to new tree set. It's a basic constructor. So it will create an empty tree set object. So elements will be inserted according to default natural sorting order. Okay. So when we take an example, so we'll see how it will be. But here the insertion order will be default natural sorting order. So ascending order for numbers and alphabetical order for strings. Okay. So another constructor, tree set is called new tree set comparator C. So it will create an empty tree set object. Elements will be inserted according to customized sorting order, which is described by comparator object. So with the help of comparator, we can write our own sorting order. So with the help of comparator, we can do customized sorting order. We can implement with this constructor. So by taking an example, we will see this one also. So this is very common for all the constructors we already see. We already saw for previous collection things. So tree set is called new tree set of collection C. Okay. So it creates an equivalent tree set object for the specified collection object. So this constructor will be helpful for interconversion between collection objects. Okay. So we have seen that null insertion is possible, but there are some conditions. What are those conditions? So null insertion is possible to only empty tree set. Okay. So null insertion is not possible to non-empty tree set and will get null pointer exception if we try to insert any other element. Okay. So with the help of an example, we will see this null insertion also. So now we'll jump into the Visual Studio Code. By taking an example, we'll see all these things. Okay. So we're not talking about all the different methods available in this. So we already saw everything in our previous collection objects. So collection classes and interfaces, same thing is applicable here also. Whatever is new here, we will discuss those things. So I have created one class called tree set demo. So we'll try to, so tree set TS is equals to new tree set. Okay. So now how to add elements, right? TS dot add of, I'll add small a, TS dot add of D, add of C, capital C, capital B, capital S, TS dot add of capital A. So we added 1, 2, 3, 6 elements. Now I'll try to print this one. What is the T's? Okay. So what could be the output? Right. We don't know, insertion order is not preserved. So it will be inserted with default natural sorting order. So we cannot predict how the insertion order. Okay. So first we'll try to execute this and we'll understand how it is working. So Java treeset demo.java. Sorry, I mixed this .java.util. You see that the order is this one. First capital A, capital B, capital C, capital D, capital S, and A. So what is the insertion order here? Right. So it will, if it is string, alphabetical, but alphabetical means there are small a and capital A, means capital letters and small letters. So it will consider ASCII values or hash code values. So then if you see the ASCII value of A, it will be like 95 and capital A might be 64. And so I'm not sure, like it very similar, means very near to that number, but overall that the capital A is smaller than small a. Okay, so that is what we need to understand here. And then now if you try to see what is internally happening, so when you try to add a, so it will be adding a. Okay, so but when it's try to D, it will compare D to A. Okay, so D is greater than A or not. So if it is not greater than A, it is false, then it will return minus value. It might be anything, minus value. It might be -1, -2, -3. We don't bother about this number, but we are concerned about this sign. So it will be negative. Okay, so if it is negative, it keeps adding this direction. If it is positive, it keeps adding this direction. Okay, so now it added A at the first time. There is no comparison, right? There is no sorting order, there is no comparison. If it is D, D means what, where it will be. So D's ASCII value is less than. Okay, so less than means it will return -1. So it will be this order, left order. So it will be D here. Okay, then C it will compare to D. So D, C is less than that. So it will add here. Okay, so B, again B here. Yes, yes to B, it's greater than to B. So right side. Again we have C, greater than to C, right side. Greater than to D, right side. Left means less than to A. So it will be here. Then A is less than to B. So A, B, C, D, S, A. So this order it will store. Okay, so this is how. If it is positive, this direction, right? Now, so we understand this logic, right? So now what we will do, let me clear this. Now what I'll try to do, ts dot add of null. So null insertion is possible, but we said some conditions, right? Let me print again. Here I can say null insertion. So if I try to execute, we will get null pointer exception, right? So if you try to add any, basically what we discussed here for the null insertion is not possible to non-empty tree set, right? Simply, if it is non-empty, it is not empty. So we have 6 elements to this, inside this. So if you try to add null to this, so it is not possible. The reason is here we are comparing with the elements, right? So how can I compare null to A? I can compare homogeneous objects, not heterogeneous objects. Because of that, heterogeneous objects are not allowed in tree set, and null for the first time we can add, but if you have any elements you cannot add. So if you try to execute, use a null insertion. But if I try to comment this, okay, if I try to comment this, so for the first time there is no element, it is empty tree set. For the empty tree set, I'm adding null. So we'll try to execute and see. Key1 is null. What is that? Let me execute again. Let me look into this. So it is giving me a null pointer exception even if there is no other elements, and this is not possible. Whatever we discussed here, this is old information, like it will be until Java 1.6. Okay, even I'm not aware of this. So null insertion is possible with these conditions before 1.7 until 1.6. But if you have latest Java, even it will not allow if you do not have any elements. Okay, so ignore this topic. So means just an idea as a knowledge, but you cannot add null. Even null insertion is not possible for empty tree set also. Okay, it is not possible for empty tree set also. So that is one thing. And let me uncomment this. So if I try to add heterogeneous objects, means ts dot add of, I'm adding 10 integer. So I cannot compare even 10 to A, B, all this, right? These are all strings. This is integer. So what you will get? Okay, here also we can mention null pointer exception. Okay, please ignore this. So this slide is not applicable now. Okay, so now if I try to execute this, you will get class cast exception. You see that? Class cast exception. The reason is, so we cannot add heterogeneous object. Not possible. Okay, so we cannot add null values and we cannot add heterogeneous objects. Not possible. So let me comment this. Now we have seen how to add values to the tree set and how it internally works, how it is adding. Okay, but this is default natural sorting order. But I want to change my sorting order according to my own requirement. Okay, let's take an example of reverse of this. So it is ascending order. I want to make it descending order. Okay, so how can I do that? So for that, we will take another tree set. Okay, let me comment this also. Tree set TSC, something like that, is equals to new tree set. What we need to take? So comparator, right? Constructor. What is the constructor we have seen here? So comparator. we need to provide comparator object. Okay, so I can take comparator object, new, I can say custom comparator. So custom comparator I'll take. So I will add some values to this. tsc.add of 10. So let me change these numbers. 10, 5, 35, 23, 8. Some random numbers I have taken. This time I took integer values. So system.out.println tsc. Okay, just for few seconds, remove this and try to execute. Forgot this one. You see that 5, 8, 10, 23, 25. Insertion order is not preserved. So according to default natural sorting order, that is ascending order, 5, 8, 10, 23, 25. But I want this reverse order. Okay. So I'll put, sorry. So comparator. So I need to implement this comparator, the logic. Okay. So I need to, so that is a class. So I'll do for descending order. Okay. So class custom comparator. So it implements, sorry, comparator. Okay, it implements comparator interface. So what is the method available in the comparator? We have one of the methods called compare. So oblique int compare. Okay. Why it will return integer? That already saw, right? If it is positive, it will return positive number, negative number, the same thing. Because of that, compare will return integer. So positive number, integer. So I'll take integer. So it will accept two objects. Okay. Object O1, comma, object O2. Right. So these are objects. So I need to convert into integers. So I'll typecast this. So integer O1, and the same way O2 to I2. Okay. So now we'll implement the logic. So if I1 less than I2, okay, if I less than I2, so now I1, first one, we are comparing with the second one. If it is less than means what? Normally left side it will add minus, but here I want reverse. So I'll make it return positive number. You can give +1, you can give +20, whatever it is. Don't bother about this number. Just plus symbol or minus symbol we need to bother. Okay, we need to concern about. So if I1 is greater than I2, so reverse, right? Return -1. So else, sorry. So else return 0 means duplicate elements, right? So both are same means duplicate elements don't allow. Okay. So now I implemented this logic descending order. Now what I'll do here. So I implemented, right? So first we'll try to execute this and we'll see the output. You see that 35, 23, 10, 8, 5, reverse order. Right, this one. So how it is working? So if you take this, The first value is 10, right? So 5 we are comparing with 10. 5 greater than 10, right? So I want to add, 1 second. Let it be like this. So 5 greater than 10. So minus 1. We are comparing 10. Let me drag a little bit. So here I1 less than I2, right? So I1 less than I2, plus symbol, right? This is positive. Let me. So it will give me positive value, return positive value. If it is I1 less than I2, it is satisfied, right? Positive means this direction. So 10 will be here, means 5 will be here. Now, what is the next number we have here? Right. What is the next number we have? 10, 5, then 35. Right. So 35 will compare here. 35 greater than 10. Right. So then obviously what will be? Minus symbol. Means this way. So it will be 35. Then what we have? 23. So 23 less than 35. So it will come here. Right. So again 8. 8 means it will keep comparing. It will come and sit here. Right. 35, 23, 10, 8, 5. So this order. So I have written my own what is the sorting order. Okay. This is how it will work. Let me clear this. Right. So descending order I implemented. Here, if you do not have, if you take a default constructor, it will be natural sorting order, default natural sorting order, that is ascending or alphabetical. But if you want to implement your own, you need to write your custom comparator that implements comparator. You need to write the logic here. According to that, if you pass that comparator in the constructor, then that logic will be applicable. Okay. So this is how we need to implement, or we need to use tree set. Right. So we missed here this null insertion. So that is old concept. I missed that. So that is not possible now in the latest Java. Okay. So anyhow, that is a knowledge, right? Okay. So that is all about tree set. What could be the possible interview questions from here? So what is tree set in Java? What are the different constructors available in tree set? Can we add null to tree set? Right. That is not possible. So what is comparator and how to use it? So comparator, we can write our custom sorting order. So with the help of that, we can implement our own sorting order. Okay. So that's all in this video. Thank you. Hi. In this video, we will talk about map interface. Okay. So what do you mean by map? We'll discuss in this video. So if you talk about map, means it's a separate topic. So under the map, you have so many other maps: hash map, linked hash map, weak hash map, identity hash map, sorted map, hash table, properties, navigable map, tree map. So these are all comes under map interface. So map is the root of all these things. Okay. So we'll talk about this map in this video. So what do you mean by map? To represent a group of objects as key value pairs, then we should go for map. Okay. Group of objects as key value pairs. So we need to focus on this word, what is key value pairs. Okay, how it will be, we will see. So both keys and values are objects in a map. So keys and values both are considered as objects in a map. So duplicate keys are not allowed. Okay, duplicate keys are not allowed. Duplicate values are allowed. Each key value pair is called an entry. Okay, So if you have a key value pair, that is called one entry, okay, in the map. So if you take an example here, okay, so here this is a map, okay, this is a map. So map will have key value pairs. So these are all keys and these are all values, okay. For each key you have a respective value, key value, key value, key value, something like that. And one key value pair, you see that this is what I marked here with the pink color, that is called an entry, one entry, and this is another entry, okay. So this is another entry we can see, okay. So this is one entry, another 3, 4, 5, 6. In this map I have 6 entries, okay. We have 6 entries here. So this is called key. First object is called key, and the second object is called value. So these key duplicates not allowed, okay, duplicates not allowed. But for value, duplicates allowed, okay. So 1200 should not repeat in this keys, but apple can be more than one, okay. So this is how a map will work, okay. This is called key value pair. So key comma value, so this is called an entry, okay. So we'll see what else there in this. Let me clear this. So methods defined in map interface. What are the methods inside the map? Okay, object put. So in the collections, in our previous videos, we discussed about the collections. In the collections, we use to add an element, we use add method. But here, put method. So inside the put, you see object key, object value. We discussed key value pairs. Both are objects, object key, object value. To add a key value pair, this is used to add a key value pair. If the key is already available, then old value will be replaced with the new value and returns old value. So in the previous, like if you try to, how we can take this? Let's take an example. So map m dot put. So 100 comma, I said apple. Okay. So if I try to do the same thing again, 100 comma, so apple, I say banana, something like that. Okay. Then what happens inside the map? So it will search. 100 is there. It's already there. Then it will be replaced with banana. So at last you'll have only one entry. It will be overwritten by this one. Apple will be replaced with banana if you already have, and it will return the old value. What it will be? Apple. But it will not give you any error. Okay. So that's how it will work. Let me clear this. So the old value will be replaced with the new value and returns old value. Void put all. So put all, and you need to, for the map, you can add only map, right? So you will put map object, you will pass map object only to add another map. Get object key to get the specified value associated with the key. With the help of get, you can get the associated value. Remove, to remove an entry which is associated with the key. So the entire entry will be removed according to the key. Okay. So another method contains key to verify specified key available in the map. Contains value to verify specified value available in the map. Is empty to verify map is empty or not. So that is Boolean. Int size, get the size of the map, that is integer. Clear, to remove all the elements from the map. Okay. So we have some other methods also, like set key set to get all the keys from the map. Okay. So how it will be like, let's assume you have something like 1 banana, 2 apple, 3 mango, something like that. So I want only these keys. Okay. So that is with the help of key set method we can get. But what is the return type of this? Set. Why this is set? So keys are should not be duplicate. So set will not allow duplicate values. So because of that, we'll get the only unique values. Because of that, the return type is set. Okay. And we have one more like collection values, right? We have seen same thing: 1 apple, 2 banana, 3 mango, 4 banana again. Now I want only these values. Okay, values. So for that you will use values, but the return type is collection. Why collection? Collection allows, means here, duplicate values, right? It allows duplicate values. Because of that, return type is collection. Here it should not allow, the keys are not duplicates, these are unique. So because of that, return type is set. Here there might be a chance of duplicate values. Because of that, the return type is collection. Okay. The another one, set, entry set, to get entry from the map. So you will get an entry, right? So these are all unique. If you have a duplicate value, but this is different rate. So when you compare to this, unique entries, right? These are unique entries. Because of that, again, return type is set, to get the entry from the map. Okay. So because of that, this is set, key set, values, collection, entry set, set. Okay. So now, if you move further, so entry is also an interface. So we are saying entry, right? Entry also is a separate interface. So map is group of key value pairs that we already discussed. Each key value pair is called what? Entry, right? So entry is defined inside the map interface. So this entry is defined in the map interface. How it is? So if you see the diagram, you see that interface map, this related information. Then inside the interface, you have another interface called entry. Inside that, we have 3 different methods. So get key, get value, and you can set a value. So get key means you can get the key, and you see that those are objects, right? Key value pairs are objects. So it will return object. Value also object. Set value means you can set a value, means you can update the value, you can change the value. So that is obviously object. Okay. So object get key, object get value, object set value. So these 3 are methods inside this. Okay. So this is all about map interface. Okay. This is key value pairs and entry we discussed, and methods, available methods we discussed. So what could be the possible interpretations from here? What is map in Java? What are the different methods available in map? And you can say what is entry in map. Okay. So these are all possible interpretations. So that's all in this video. Thank you. Hi, in this video, we will talk about hash map. Okay. So what is hash map? We'll discuss all these things in this video. So hash map comes under map. So this is a class, map implemented class is called hash map. So what is hash map? To represent a group of objects as key value pairs, then we should go for hash map. So the same thing we saw for the map also, but the same thing, it is implementing the map, right? So the same information, same definition. So key value pairs, then we'll go for hash map. The underlying data structure is hash table. So underlying data structure for the hash map is hash table. Duplicate keys are not allowed. Okay. that we already discussed in the map. Duplicate keys are not allowed. Duplicate values are allowed, right? So insertion order is not preserved and it is based on hash code values of the keys. Okay, we cannot predict like how it will be stored. It will be depends upon the hash code values of keys, not values. Okay, so heterogeneous objects are allowed for both keys and values. Okay, we can give different type of values. Null insertion is possible for key only once, as duplicate keys are not nulled. Right. So whatever it is null, it is applicable, but only one time. The reason is, so if you try to give that, it will become duplicate key, right? So because of that, it will not accept. It accepts only once. Null insertion is possible for values any number of times. The reason is duplicate values are allowed for values, right? Because of that, you can insert null values more than once. So this is best suit for search operation. If you want to, if your primary thing is search operation, then you can go for hash map. Okay. So this is all the basic information about the hash map. So now we'll see what are the constructors available in hash map. So hash map is good. New hash map, basic constructor. So it will create an empty hash map object with the default initial capacity 16 and default fill ratio is 0.75. Means, so if it filled with, if it fills 0.75, I mean 75% of this capacity, then it will try to create another hash map. Okay. So another one is the same thing, hash map is got a new hash map, but here we'll mention initial capacity. So it will create an empty hash map object with specified initial capacity. Means apart from 16, you can give 20, 30, 40, whatever it is, you can give. And again, the default fill ratio will be 0.75 means if you reach 75% of that, then it will create another hash map. So it is an efficient way if you know the capacity, right? Instead of creating new hash map, so we can directly mention the capacity, then we can use at a time. Okay, so single shot. So another one, hash map is called new hash map, int initial capacity and float fill ratio. So default fill ratio is 0.75. Here you can give your own 0.5, 0.95, 0.99, so something like that. Okay, that is also available here. So another one is hash map is called a new hash map of, you can give another map to this. Okay, we have seen the same concept in collection. So collection C. So the same way for the map, you can add another map. So it creates an equivalent hash map object for the specified map object. And this constructor will be helpful for interconversion between map objects. Okay. So now we see with one example how hash map will work. Okay, for that, let me go to Visual Studio Code. So here I created hash map demo. Okay. So this is also from the java.util package only. So hash map hm is equals to new hash map. Okay, I took default constructor. So now I'll try to add elements. Okay, so how you can add elements? Dot put method, not add method, put method. So I'll say apple and 1200. Okay, so hm dot put. So let me take this one. The second one I can say Samsung. This is $1,000, something like that. So Nokia, what is that? 300. The next is Sony, 800. Okay, so again I'll put null comma something like 100. So null insertion is possible, right? So because of that, key only once. Okay, and I'll say Vivo null value. So Oppo null value, right? So means only one null value for key. So here as the values I have given more than once, right? So it is possible. So now we'll try to print this map. So how it will be? So previously collection is in these brackets, right? Square brackets. This is in the curly brackets. Okay, it will be in the curly brackets. And here what is that? Insertion order is not preserved. We don't know how it will add. Okay, so if you try to execute this hash map demo java hash map demo dot java, you see that this is how it added the values. Let me paste here. You see that first I added Apple, then Samsung, then Nokia, then Sony. Sony is the fourth entry actually. But here you see the first one, Sony is equals to 800, null is equals to 100, Apple is equals to 200, Vivo is equal to null, Oppo equal to null, Samsung equal to null, Nokia is equal to 300. This is how it will add. The reason is it is in the curly braces and insertion order is not preserved. Okay, so that is how it will print. Now update the value. How you can update the value? So let me system.out.println hm.put of again Nokia, comma, I made it 500. Okay, same, but if you try to give the means Nokia is already element is the key is there. You're trying to give the duplicate, then what will happen? It will replace this 300 to 500 and it will give me back 300. Output is 300 and it will update. So because of that, let me take this one and print again. So now we'll see what is the latest value of Nokia. You see that first time this one, it replaced, so it returns the old value. So returns old value. Okay. Updates new value and then returns old value. Right, that is what happened. And you see previously Nokia is 300, now Nokia is 500 new value. It got updated. Okay. So now I want to, so let me go here. Now what we'll see, get all the keys, right? Get all the keys. So keys, how it will be? hm dot, sorry, key set, right? And what is the return type of this one? Set, that we already discussed. Set s is equals to hm dot key set. So if now I try to print this one. Okay, so it will be set. Set means it will be inside the curly braces, right? Something like this. So let me execute and see. Sorry, set, right? It's not map. Sorry. So it will be in the curly braces only. So you see that only keys: Sony, null, Apple, Vivo, Oppo, Samsung, Nokia. Only we got keys. Now I want values also. Okay, get all the values. So that is hm dot values. And we saw, right, this is collection C is equals to. Okay, so again I'll print C. Here also collection also will be in the this square brackets only, right? So now I need to get all the values in the form of collection. You see that 800, 100, 1200, null, 1500. I got only values with the help of values method. Now what I can do, I want entries. Get all the entries. So we already saw what is that hm dot entry set. Okay, hm dot entry set, again it will return what set. So I'll give s1, otherwise entry set, something like that. Now I'll try to print this one. So again it will be set, because of that in the square brackets only you'll get the output. So let me execute and see the output. You see that all the entries. Now what is the difference between this one and this one? Only difference is it is in the curly braces, it is in the square brackets. Only that is the difference, because this is returning map and this is set. Okay, that's what. And now I want to get 1 by 1 value. Okay, I want to get 1 by 1 value. So how it will be? So for that we'll use iterator. ITR is equals to ES. We need to iterate over what? Entry set. Okay, so we can iterate over entry set only. We can directly give ES dot iterator. Okay, so here while ITR dot has next. So we have seen all these things in our, these are all cursors, right? Iterator is a cursor, right? We already discussed in our previous video. So now what is that entry? We need to get first entries, right? So that is, this is inside the map. Inside the map you have entry interface. Map dot entry m is equals to, so iter dot next. So this I need to convert to the typecast to this one, entry, map dot entry again. So the value which I'm getting also should be map dot entry, right? So because of that, what I'm doing, converting to map dot entry, typecasting. So now I'll try to print the system dot out dot println. So now you have inside the m is an entry, special entry, right? One entry. Entry means key value pair, right? So key value. So for that we have m is a entry. So otherwise you can say entry. Okay. So now entry dot get key is a method to get the key only. So plus, just I'll give three this one, and I'll try to print value. What is that? Entry dot get value. For the value we have get value, for the key we have get key. Okay, now I will try to execute this and we'll see how it will be. You see that key value one by one I'm getting, right? We were able to print all those things. Now I want to do one more thing. While iterating this way, we have one more method called what? Set value, right? Inside the, so what you say, inside the entry interface, we have get key, get value, and then set value, right? Where you can set value, if entry dot get key is equals to apple. If it is apple, then change the value of that. Entry dot set value to 1500. Okay, now we'll try to print this one after updating. System dot out dot println hash map. Okay, so let me, okay, so after updating I'm trying to print, I need to see what is the value of apple now. Okay, Let me go and execute. What is the apple value now? 1200. It should become 1500. So where is the apple? You see that apple is 1500. Before updating this 1200, after that 1500, it is updated successfully. So with the help of set value, you can change the value of any entry value, only value, set value according to your key. Okay. So other methods are all. We have so many other methods that you can add map to the map, hash map to another map. So all these things we can do very similar, but this is very important. So add elements, update the value, get all the keys, get all the values, all the entries, one by one value, you see. Okay. So this is all about hash map. So what could be the possible interview questions from here? What is hash map in Java? And what are the different constructors available in hash map? Okay. So they can ask what is entry also in the hash map. So key value pair, one key value pair is entry. Okay. So that's all in this video. Thank you. Hi. In this video, we will talk about linked hash map in Java. Okay. So what is linked hash map? So here it comes under hash map. This is child class of hash map. So all the methods inside the hash map can be used in the linked hash map also. So linked hash map is child class of hash map. The underlying data structure is combination of hash table and linked list. For hash map, that is hash table, but here the combination of hash table and linked list both. So insertion order is preserved. In hash map, insertion order is not preserved, but here insertion order is preserved. That is the only difference between hash map and linked hash map. Okay. So we'll see by taking one example. Let me go to Visual Studio Code. So here I created linked hash map demo. So first I'll create linked hash map. LHM linked hash map is equals to new linked hash map. Okay. So here, so let me take as hash map. I'll tell you why. So now I'll try to add the elements. Okay. Add elements. I'll add the same elements which we added in the hash map. Okay. So I'll copy paste from here instead of writing again and again. So only this is the difference we can see, right? So add elements. So put Apple 1200, Samsung 1000, Nokia 300, Sony 800, null value is 100, Vivo null, Oppo null, and insertion order is preserved. That is the only difference. Okay, that is the only difference, and we will see what exactly the output will get. Okay, so let me go to here and Java linked hash map demo.java, and you observe now the output. Apple first, Samsung, Nokia, Sony, null, and Vivo, Oppo. So how we added the same order, it is added into the map, right? This is the output, right? This is the only difference between what hash map and linked hash map. Apart from that, so we can have everything as it is. You see, update the value. So we'll just copy paste and execute. So instead of writing all these things, no need to discuss all these things, but just so updates the new value and returns the old value, right? So it should give me 300 back, right? You see, 300, and the Nokia value is 300 to 500. Okay. In the same way, get all values, get all keys, and get entries. So let me put all these things. So because of that, I changed that LHM to HM. I can easily copy paste and execute, right? You see that this is keys: Apple, Samsung, Nokia, Sony, null, Vivo, Oppo. These are all values: 1200, 1000, 500, 800, 100, null, null. And these are all entries: Apple, Samsung, the same order: Apple, Samsung, Nokia, Sony, null, Vivo, Oppo. Right. So that's how we can do. And the same way, last one by one value, there is no change, same thing. Okay, and I'll try to print this one also. So because of that, I did not change the object value LHM. I changed LHM to HM. So the same thing. So we'll try to execute. You see that? And it printed the same order: Apple, Samsung, Nokia, one by one value, and Apple value changed from 1200 to 1500. Here 1200. Now it changed to 1500 as we set the value. Okay. So if you watching directly linked hash map, just try to watch hash map also, then it will be very clear. Okay. But what is the difference between these two? Except insertion order, everything is same. Because of that, I want to show that. So I just copy pasted directly from the hash map demo and executed. Everything is working fine. Means only this is the difference. Insertion order is not preserved in the hash map, but that order is preserved in linked hash map. Okay. So that is all about linked hash map. What could be the possible interview questions from here? So what is linked hash map in Java, and what is the different constructors available in linked hash map? You can use the same constructors we have seen, right? And you can see a difference between hash map and linked hash map. Okay, that is also one of the possible interview questions. Okay, so that's all in this video. Thank you. Hi, in this video, we will talk about identity hash map in Java. Okay, so what is identity hash map? So that comes under directly in the map. So identity hash map comes under map interface, it's a class. Okay, so identity hash map is similar to hash map. So it is almost similar to hash map. But what is the difference? Hash map uses dot equals method to identify duplicate keys, which is used for content comparison. Okay, and identity hash map uses double equal operator to identify duplicate keys, which is used for reference comparison. Okay, so this is the difference between hash map and identity hash map. So apart from this, everything is same. So only what is the difference is hash map internally uses dot equals method to identify duplicate keys. So if you're trying to add keys, it will verify with equals method whether the already key is available in the hash map or not. But when it comes to the identity hash map, how it identifies, how it compares the keys using the equal operator. That is the only difference. But dot equals method we will use for content comparison. But double equal method we'll use for reference comparison. Okay, so that is the difference. So if you take an example like this one, so I have taken integer I1 is equal to new integer of 10. So I1 value I declared as 10, integer I2 equal new integer of 10. So again, I2 is also 10. So this is 10 and this is 10, but this is I1, this is I2, right? So now you see that this is 10 and this is I1 pointing to I10, right? Internally pointing to I10. Another value 10, but this is I2 pointing to this 10. Okay, but what is happened if you use I1 equal to I2? So this is reference, right? Reference means I1, I2 not referring to the same value. Okay, so if it is something like that, how it will be? So if I2 is also pointing to this, then it is true. But this is not the case, right? I1 is pointing to this value 10, I2 pointing to this value 10. Both are different. So because of that, both are not referring same. So this is false. But I1 equals to I2. This equals will compare content. So the content is 10 here, content is 10 here. So it will return true. Right, we need to understand this concept too for the hash map and identity hash map. Right. Equal means return reference values. Both are not referring to the same values, because of that it false. But equals, look into the content, what exactly content inside the what exactly I1 I2 referring to which content. Both are referring to the same content, that is called 10. So because of that this is true. Okay, so now let me clear this. Now we'll go to Visual Studio Code and we'll try to see what exactly the difference. Okay, first I'll take hash map to see the difference. Hash map hm is equals to new hash map, and then I'll take the same example. Integer I1 is equals to new integer of 10. Okay. So I2. Okay, now what I'll do, hm dot put of I1 comma I1 is value is apple. Okay, hm dot put of I2 comma I'll say Samsung. Only two values I'm taking. So now I'll try to print system dot out dot print ln hm. Okay, so what could be the output for this? Okay, so what could be the output for this? Now it will first time adds I1 is equal to what? 10 is equals to apple, right? 10 equals to apple. The second time I'm giving I2. I2 is also what? 10. Okay, but now it will compare. This is I1, this is I2, this is also 10. It will compare using what? Dot equals, right? Using dot equals. So dot equals will do what? One second, we'll go back to here. So here I1 dot equals true. It will match for content, right? So it will look for the content. Now it is looking for the content. Dot equals means what I1 value, what I2 value, both are 10. Okay, so if it is 10, already 10 is there. So now what it will do, 10 value will be replaced with Samsung. The reason is duplicate values are not allowed. Sorry, duplicate keys. Duplicate keys not allowed. Right here, but what it is doing, using dot equals method. Dot equals method will use what? Content comparison. So content comparison. What is the content of I1 is equals to 10 and I2 is equals to 10. Both are matching. So if you try to do 10, 10 already there. So if 10 is there, duplicate keys are not allowed. So ideally what it will do, if you try to give the same thing, it will update the previous value to the latest value. Now the output is what? 10 is equals to Samsung, right? That is what we need to get once you execute this. Okay, so how it will be, this is map and 10 is equals to Samsung. I need to get this value, right, according to the concept. So let me execute. What happened? Has been deprecated and marked for removal. One second. So if you observe, the output 10 is equal to Samsung. But there are two warnings. These are not errors. Warning. What they are saying is integer int, this constructor has been deprecated and marked for removal. So not yet removed, but they will remove that in the coming versions. So what you see, it is giving me output 10 is equal to Samsung. That is what we have seen, right? So then how to resolve this? I think resolve means I am assuming this will work. Let me try to execute. So it's not there. So we'll see that later, but at present it is not, it is working. So, but they are giving warning that these are deprecated. Okay. Now, this is hash map. The behavior is something like that. But if you take identity hash map, then this is looks for the reference. Both are not referring to the same. So what it will happen? It will allow duplicate keys. Okay. So what is the result of that? So because of this operator, it will only look for the reference. So then it will allow duplicate keys, right? So we'll see the same thing. I will copy paste the same thing. Same thing, but I just change the class name is identity. Okay. So identity hash map HM is equal to, sorry, new identity hash map. That's it. Okay. That's it. But here I1, I2 both are 10, but internally in identity hash map is not looks for the content matching. It will looks for the reference matching. So both are not referring to the same. Then what I'll get? I will get 10 Samsung, 10 is equals to Apple. Both will come. It means now it is accepting duplicate keys. Okay. So now if you try to execute this, you see that 10 is equals to Samsung, 10 is equals to Apple. Okay. So that is the only difference when you talk about identity hash map with respect to hash map. Okay. So remaining things will be same as it is also implements map interface, right? Remaining methods, everything you can as it is how you use it in the hash map, the same way you can use in the identity hash map also. But the difference is this one. So here it will compare content equality, but here it will content reference equality. So because of that, here it will update the old value to the new value, but here it will not. So it will give me the two value. It will add the two entries. The two key value pairs means two entries. That is the only difference between the identity hash map and hash map. Okay. So what could be the possible interview questions from here? What is identity hash map in Java, and what is how it is different from the hash map? It is, so it will accept duplicate keys. The reason is it will look for the equal operator. It will internally use, and that will use it for the reference equality. But in the hash map, it will use dot equals method that looks for the content equality. Okay. So that's all in this video. Thank you. Hi. In this video, we will talk about weak hash map in Java. So what is weak hash map? We'll see with the help of one example. So first we'll see that weak hash map comes under this map, and here we see weak hash map. So we are talking about this weak hash map. It is a class. Okay. So weak hash map is similar to hash map. So we already discussed about hash map, right, in our previous videos. So it is very similar to hash map. But what is the difference between hash map and weak hash map? So in case of hash map, if it is a hash map, object is not eligible for garbage collector, even it doesn't have any reference and associated with hash map. Okay. So normally, if you do not have any reference, then garbage collector will destroy that object, right? But here, if object is the object is not eligible for garbage collector, even it doesn't have any reference and associated with hash map. Okay, if it is associated with hash map, it is not eligible for garbage collector. But if it is in case of weak hash map, object is eligible for garbage collector, even it doesn't have any reference and associated with weak hash map. Okay, so that is the only difference between hash map and weak hash map. So with the help of an example, we'll understand what exactly it is. So first, let me explain you this. So I have a map. Okay, and I have a class. So I have a class called language L is equals to new language. Okay, I have a class language is L is equal to new language. And in the map, so in the map, let's assume map.put. In the map.put, you can put key values, right? So, and key and values both may objects also, means this could be objects also, right? K is also object, V is also object. So here, m.put, I'll put object instead of K, I'll put L. So L is an object to language class, and that language is some language. Okay, so I have this something like this. So then you have L. L is an object. So this is L, and I'm storing this L in here as a key, and the language is value. Okay, so here I have a class language L is equal to new language. For the key value pairs, I can store objects also. So because of that, I'm storing object. What is that object? L. And what is the value? Language. I'm returning language. So this is an object I am putting as a key value. So what is the reference to this object? L is the reference as we created L. So if I deliberately I made object is equals to null. L is equals to null. So now you do not have a reference to this, right? If you do not have any reference, this object is eligible for garbage collector, and garbage collector will destroy this. But here there is another link. Okay, so it is associated with map. If this map is hash map, then this is not eligible for garbage collector. But if it is a weak hash map, then this is, even though if it is associated with here with the map, this is eligible for garbage collector. Okay, if this map is hash map, it is not eligible for garbage collector. If this map is weak hash map, this is eligible for garbage collector. Okay, so how we can see with an example? So I'll take an example. I'll try to explain you this one. Let me clear this first. So let me go to Visual Studio Code. So here I created one class called weak hash map demo. All right. So let me create a class called language. Okay. And for each and every class, we will have a toString method, right, inside that. So that I will override. How I'll override public string toString. So simply I'll return what? Some value. What is that? Language. Okay. I will return language. And when there is a garbage collector, right? Then garbage collector, what it will do? It will call finalize method to clean up some activities, right? So I will write public void finalize method. Why I'm writing, I'll explain you. whether it is calling or not. System.out.println. So I'll write some dummy information. Calling finalize method just to check. All right. So I created a class called language. In that I overridden toString method and I'm returning some string that is called language. Right. And I am implementing finalize method. So when it will get called, when you invoke garbage collector. So with the help of this class, we'll try here one example. So what we will do here, first I'll take hash map. How the behavior will be with the hash map and with the weak hash map. Hash map hm is equals to new hash map. And then I'll create an object to language. Lang is equals to new language. Okay. And as we discussed, hm dot put as a key value pairs, I can put objects also, right? So I'm putting one object called lang, that is language class object. And what is that language? I just mentioned Java. Okay, whatever you can put as a string, I'm taking as a string. Now, if I try to print the system.out.println hm, right? So if it is that simple, then we will try to execute and see how the behavior is. So what is this lang object? What it is returning? Language. So it should be language is equals to Java. So first let me execute this. You see that language is equals to Java, right? This is what I'll get the output. So now till here it is very common, right? Now I will make this object is equals to null, right? I'll make this object is equals to null. When that is null, so I will call gc method, garbage collector method, system.gc to invoke garbage collector, right? After that, what I'll do, I'll put a thread.sleep, forcefully stopping my program execution for 3 seconds, 3000 milliseconds. So it will return exception, throws exception. It will throw actually interrupted exception, but I'm taking exception. After this, I will print again. Okay, I will print the map again, hash map again. Okay, so here you just understand what is happening. So here till here we understand, right? I can put any object. So I'm putting language object and the value is Java. So whenever you call object, it will call internally toString method. ToString method is returning language. So because of that, language is equals to Java. Till here it is fine. But I'm forcefully making null. This language is equals to null. So then the language object is eligible for garbage collector. So I'm calling garbage collector. If it is garbage collector, right? So what happens? If this object is destroyed, language Java, and if it is garbage collector, if it is destroyed, then key will not be there. If key is not there, value will not be there. Then it will become empty map, right? It has to print empty map, right? I made it null, right? After null, if I'm calling garbage collector, finalize method will call and it will destroy this object. If it is destroy this object is there where I'm storing here. So it is not there. If it is not the key value pair means if it is there is no key, there is no value. So it will become empty. So I am expecting empty here. Okay. So normally the behavior should be like that. So let me clear this and execute this again. And observe the behavior. First it will print language and 3 seconds waiting. And you see that again language is equals to Java. Print after making null also. After making null, and I'm calling GC. GC means it has to call this finalize method, but it is not, if it is calling finalize method, this has to print on my console. It is not printing on my console means it is not executing. That is what hash map. In case of hash map, if you make it is null, this object is not eligible for garbage collector as it is linked with hash map, associated with hash map. Okay, so then we'll try to use weak hash map. Okay, then we'll see the behavior. Okay, that's it, only that change. So go there and execute. Now you will get the empty. You see that here empty, and you see it is printing, calling finalize method just to check. Why it is calling? Finalize method is calling means what? GC executed, garbage collector. So when you have hash map, it did not happen. But when you change it to hash map, then it became null and it is eligible for garbage collector. So finalize method executed, it became empty. So now it became empty map, right? Empty map it became, right? So that is the only difference between hash map and weak hash map. Apart from that, everything, whatever you perform in hash map, you can perform everything with the weak hash map, right? So to explain that, I have taken another class and I overridden toString method and I have implemented finalize method to see the behavior exactly. Okay, if it is hash map, if you call GC method also, it will not applicable on this language object. But if it is weak hash map, it is applicable. So it became null. Because of that, there is no value. There is no value for the respected key. So it became empty. Okay, so that is what all about weak hash map. Okay, so what could be the possible interview questions from here? So what is weak hash map and how is it different from hash map? We have seen that, right? So that is the different. Okay, so that's all in this video. Thank you. Hi, in this video, we will talk about sorted map in Java. So it is an interface. So when you see in this tree, so it comes here as a sorted map. So we'll talk about this sorted map in this. So sorted map is child interface of map. And then sorted map is to represent a group of key value pairs according to some sorting order of keys. So it depends, the sorting order depends upon the keys only, and sorted map will have key value pairs according to some sorting order. So what are the methods available in this interface? So object first key, it returns first key. Object last key, it returns last key. Sorted map, head map of object key. So in this method, so if you talk about this, returns a sorted map. The return type of this head map is sorted map again, whose these keys are less than specified key object. So if you have multiple keys inside that, so the values already is sorted in the sorted order. So the key which you mentioned less than those keys, it will come as a sorted map, means it will return as a sorted map. If it is sorted map tail map, it returns sorted map whose keys are greater than or equal to specified object, means specified key. This one. Okay. So sorted map submap. So submap of this key 1 and key 2, both objects, returns it. Again, it is also written sorted map whose elements are greater than or equal to this key 1 and less than of this key 2. Okay, those values will be, you will get as a sorted map. Comparator method returns comparator object that describes underlying sorting technique, right? If you will have your own sorting technique, otherwise it will return null if you use default natural sorting order. Okay, If you take an example here, so what happens here? Have a sorted map, right? 100, 101, 102, 105, 110, 121, 150, 200, 205, 215. So everything is sorted, right? Default sorting order. So ascending order it is, as those are numbers, ascending order it sorted, right? So in this, if you apply those methods, first key, so this is the first key, so 100, it will be 100. Last key, it will be 215, right? So head map of 105. So 105 means less than this key, right? Less than 105. All the elements before this. So what are those before? 100, 101, 102. You see that 100, 101, 102. 100 equal to A, 101 is equal to B, 102 is equals to F. This is map, right? So it will print like this. So if it is tail map of 150, greater than or equals to, right? Greater than or equals to 150 and above 150. So from here, so you'll get 150, 200, 205, 250. You see that? 150, 200, 205, 250. So this is how it will print. Submap of 121, 205 means greater than or equals to less than of 205. So 121 to less than 205. So 121, 150, 200, only these three, right? 121, 150, 200. These values, it will give me as a submap. So comparator, we have default natural sorting order. So we'll get a null value. Okay. That is all about sorted map. Okay. As it is interface, you need to use some implemented class to implement this. Let me clear this. So what could be the possible interview questions from here? What is sorted map in Java? So methods available in sorted map. Okay. So that's all in this video. Thank you. Hi. In this video, we will talk about tree map in Java. So tree map is a class. So we'll discuss about this tree map. So in this tree, the tree map comes under here, under the navigable map. Okay. So it comes under sorted map. Both are interfaces. This is implemented class. So if you talk about tree map is a class which implements navigable map interface. So the underlying data structure for tree map is red, black tree. Okay. The underlying data structure is red, black tree. So duplicate keys are not allowed. So in the map, we cannot store duplicate values. So duplicate values are allowed. Insertion order is not preserved, right? So insertion order, we cannot predict how it will be. So keys should be homogeneous and comparable if we depend on default natural sorting order. Otherwise, we'll get class cast exception. So in the tree, what kind of values you can store? Homogeneous elements only. So if it is homogeneous, it should be comparable with one another. Otherwise, you will get class cast exception. Okay. So keys can be heterogeneous and non-comparable if you have custom sorting order. Right. If you try to implement your own custom sorting order, then you can implement heterogeneous objects and non-comparable. So that logic you should implement. Values can be of any type, homogeneous or heterogeneous. There is no restriction, but we are mostly depends upon the keys in map. So map should be homogeneous if your depends on default natural sorting order. Otherwise, you can store heterogeneous objects also. Okay. So that is all about tree map. So what are the constructors available in tree map? So tree map is equals to new tree map, the basic constructor. So it will create an empty tree map object and keys will be inserted according to default natural sorting order. If you use this constructor, the keys will be inserted according to default natural sorting order. Because of that, you need to use homogeneous objects only. So another constructor is tree map is equals to new tree map of comparator object. Okay. So what it is comparator? It will create an empty tree object. Keys will be inserted according to customized sorting order, which is described by comparator object. Means, so in the comparator, you will write your own logic for the insertion, right? The comparison. So with the help of that comparator, you can use your own customized sorting order. So another constructor is tree map. Tree map is equals to new tree map of map M. You can use another map as an, so it creates an equivalent tree map object for the specified map object. So as a parameter, you can give another map also. So then it will create an equivalent tree map object for the specified map object. Okay. So this constructor will be helpful for interconversion between map objects. Okay. So now by taking one example, we'll understand everything. Okay. So let me go to Visual Studio Code. So here I created one class called tree map demo. Right. First, I'll try to create tree map. So TM is equals to new tree map. Okay. So TM dot put, I'll put homogeneous objects. So I'll say AAA, comma 10. Okay. Let me copy paste 3 more times. So this value is 20 and this value is SSS. So this one I'll take it as 35 and this is KKK and this is LLL and this is 50. Right. It's a very simple tree map. I just inserted some values. Okay. If I try to print this, system.out.println TM. Okay. So if I try to execute, so insertion order means it will take default sorting order. If it is default sorting order, first it will take AAA, then SSS it will compare. So SSS will compare after AAA. So if it is a string, you can take this as now alphabetical order. Right. So kind of. Okay. So let me go and execute this. Java tree map demo.java. Right. If it is strings, ascending order. You see that ascending order. Default sorting order is ascending order. Right. First AAA, then K, then L, then S. Right. Default natural sorting order is ascending order. If it is string, if it is integer. So this is alphabetical order, that is ascending order. So if it is numbers, ascending order. If it is string, alphabetical order. Right. So it is printing as by taking alphabetical order. Now if you try to insert heterogeneous objects, I take 100 comma 250. Right. So while inserting with the string, I cannot compare integer. Right. Because of that, what I should get? Class cast exception. Okay. If you try to execute now, you see that class cast exception that cannot be cast to integer. Right. This integer, I cannot do that. So you cannot compare with this 100 to this triple. So because of that class cast exception, you will get. Right. So this is very simple tree map. Now I want to implement my own logic. I want reverse of this order. This is alphabetical order, right? Reverse order I want. So for that, I will implement my own custom comparator. So class custom comparator implements comparator interface. So inside this, public int compare. So in our previous in this tree set, we have seen already this one, right? We compared everything. You see, comparator I have written in convert every object into, I converted into this one. If it is less than this, it should be +1, -1, something like that, right? So you can watch that video. The same kind of thing, right? Compare. So object obj1 comma object obj2, right? So I'll take string s1 is equals to, I will convert this object into string. So obj1 dot toString, right? The same way, string s2 is equals to obj2 dot, sorry, toString. Okay. So now return. Okay, return. So how it will be? It will compare internally, right? So let me tell you that. So you have first element AAA, right? While inserting first one, we don't need any comparison. But when you comparison with this triple S, so this triple A, so obj1 dot compare to method to obj2, right? What is obj1? What is obj2? So which is already there in the map is obj2, okay, which you are going to insert, okay, that is obj1. So triple S dot compare to triple E, okay, that's how it will work, right? So if this is the case, if it is default natural sorting order, internally it calls like this, right? Internally it calls like this. So means this is what is like alphabetical order, right? So for that, if you want a reverse of this, so normally how it will be, you compare these two values, it returns negative when it will be obj1 has to come before obj2, before obj2. So returns positive when obj1 has to come after obj2, right? It returns 0, then both are equal, right? Both are equal means 0. Don't insert this. Duplicate keys are not allowed, right? So here when you comparing this one, so triple S, right here what it is, so triple S compared to triple E. So triple S has to come what after this one, right? So after means, so it should be positive, right? In the default natural default sorting order. So in this scenario, it will give me positive. But in this scenario, I want to get negative value. Then AAA comes before triple S, right? So in the natural sorting order, it where it came after AAA, triple S come means it is coming after this obj1. That time we are getting positive value. So if it is returning positive value means triple S is inserting after triple A. But I want the reverse of this one. So in this scenario, I want a negative. So here I need negative. So then what I'll do, return, what I need to return, s1 dot compare to s2, right? Compare to dot s2. So if it is, give me positive or negative number, right? it expecting integer, it will return positive or negative. Positive means it might be any number. We don't bother about the number, we bother about the sign, positive or negative. If I put minus here, so if it is positive, I'm making negative. If it is negative, I'm making positive, reverse of that. So minus symbol will work here. So now let me clear this. Clear. Now what I'll do, I'll take the same example again. So tree map, everything. I'll put here. Here I'll put what? New custom comparator, right? That comparator we need to pass, right? So same, I'll make it TM1. Okay, TM1. So I don't bother about this. So I am implementing my own logic. Even then will observe the behavior. The reason is now what I'm doing, S1 dot compare to S2 means this is internally already happening here with this tree map. No need to implement, but to understand that I implemented the same thing what is already internally there. So in this time, if I already using new custom comparator, even then also I'll get the same output. Why? Here I'm comparing S1 dot compared to S2. Internally, it is happening same, this one only, right? But I'm writing explicitly to understand you. If you try to execute now, both the times you will get the same. What is that? This one. Sorry, there is a typo. Compare to. Now try to execute this. Both the times you will get the same output. You see that? No. In this scenario, if you want to compare like this, no need to write your own custom comparator. By default it is. But I want reverse of that. So I'll make minus here. Okay. If you get positive, it will return -1. If you get negative, it will return positive value. So now it should become reverse of it. So let me execute this. Same thing. Sorry, I'm printing the TM object. So I'll remove this one. Now first we'll execute again. The reason is I'm using TM only here, printing. So first without negative, you see both the maps are same. Now if I put minus here and I'll save, if I try to execute, you'll get the reverse order of that. You see that? Triple S first, then triple L, triple K, triple E. Right. So this is how you can implement your own logic here. According to this logic, these values will be inserted. Here I just took only reverse order. So instead of putting -1, you can do this way also. So make it S1, S2, don't use minus. So reverse of comparing these two objects also will give you the same output. You can put minus or you can interchange this S1 and S2. You see that? Same output. Right. So this is how you can implement your own custom comparator. Here I implemented reverse order. Because of that, I am getting the reverse order when inserting the values. Okay. So this is all about tree map. Okay. This is all about tree map. So what could be the possible interview questions from here? So what is tree map in Java? What are the different constructors available in tree map? So what is comparator and how to use it in the tree map? So that is what we have seen, right? Okay. So that's all in this video. Thank you. Hi. In this video, we will talk about hash table. This is a class in Java. Hash table is a class in Java. We'll talk about this hash table. So under this map, so it will come, hash table comes under this map. You see here, hash table. So then we'll talk about this hash table. So what is hash table? The underlying data structure for hash table is hash table. Okay, so hash table data structure is hash table only. So duplicate keys are not allowed. Duplicate values are allowed. The same thing as it is comes under map. So insertion order is not preserved and it is based on hash code of the keys. So hash code values of the keys, according to that, it will insert into the hash table, right? It is not preserved. It depends upon the hash code of the keys. So heterogeneous objects are allowed for both keys and values. So heterogeneous objects are allowed for both keys and values. Null insertion is not possible for both keys and values. Here you cannot insert null value for both key and value. So we'll get null pointer exception if you try to insert null. Okay, if you try to insert null as a key or value, you will get a null pointer exception. Okay, so what are the constructors available in hash table? So hash table is equals to new hash table, the basic constructor. So it will create an empty hash table object with the default initial capacity of 11 and the default fill ratio is 0.75. So the moment it creates, it fills 0.75%. So it will create another hash table. Okay. So constructors, another constructor is hash table is equal to new hash table. You can give your own initial capacity. So how many value means the entries you can put into the hash table. So it will create an empty hash table object with specified initial capacity. So it is an efficient way if you know the capacity. So you have prior information. Okay. So another constructor is hash table is called new hash table, int initial capacity and float fill ratio. So the default fill ratio is 0.75, but that also you can give your own value. Okay. So it will create an empty hash table object with specified initial capacity and default fill ratio is specified fill ratio. You can give 0.6, 0.9, something like that. When it reaches that percentage, then it will create new hash table. Okay. And the last one is hash table is equals to new hash table of map. Okay. So it will create an equivalent hash table object for the specified map object. So what is the use of this? This constructor will be helpful for interconversion between map objects. Okay, these are all 4 constructors available in hash table. So how the internal logic will be, how the hash code means, how with the help of it depends upon hash code we mentioned, right, the keys. So how it will be inserted internally, we'll take one example and see here. Okay, so here I have one hash table. So let me annotate this. So here I have a hash table. Hash table is called new hash table. This is basic constructor. So for this, what is the that the default value of this 11 with 0.75%, that is fine. But you can insert only 11 values. Okay. So HT dot put 5 A, 1 B, 7 C, 15 D, 23 E, 16 F. So before going to this, first we'll write the let me clear this. First we'll write the program and we observe the output, and we'll go back to the diagram and talk about that. So hash table T is small. In the hash table T is small. HT is equals to new hash table, and I'll try to put some values. Hash table will put 5 comma A. Okay. Let me take this. Okay. So let me put this one 5, 1 B, and then C, S7, and D, 15. Instead of 5, I'll take 23, E, F, this is 16. Okay? So I have taken these values and I will try to print this one. System dot out dot println ht. Okay, right. So here, how it will be stored? Hash code of this key, right? If it is integer values, you don't know. Okay, we'll do one thing. For integers, we don't have any problem. Okay, first we'll take as it is. I'll take again another hash table. Okay, here I'll put capacity as 30. This is 11 and this is 30, and I'll make it ht1, and let me change all these things. Same values, and you observe the output. Okay, so I have taken with default value 11, and I have taken another constructor. Initial capacity is 30, and I'm inserting the same values. Then you see the difference between these two. So let me execute this. Java hash table demo.java. You see that different outputs were these different constructors. Strange, right? So there also I have 6 elements. Here also I have only 6 elements. 1, 2, 3, 4, 5, 6. Here I have capacity more than this 11. Here also I have the capacity more than the 6 elements. Even though with the 11, with the 30, I have different output. You see? And I don't know how the output is coming. Right? So that is the different according to this hash code. Because of this hash code, the output is different. Right? So if it is integer, we don't bother about the hash code. By default, it will take as this, what do you say, ascending order. Okay, but I'll implement my own logic. Okay, I'll create another class. So if it is string or something like that, we don't know. So because of the, to understand that class hash code value, I'm just giving one name hash code value. So I'll take int I. I'll create a constructor hash code value. Here also I'll pass int I. Inside this, I'll assign that value to this one. This dot I is equals to I. Okay. And public int, I will use hash code method. This will return I value. Whatever I value, I'll give the same value. Here I'll public string to string, I will override. Why I'll override, I'll tell you. Return string dot value of I. I'll convert that integer value to string and I'll return that. Okay. So what I'll do here, I'll take one more hash table. Okay. So I don't know the hash code value, how it will be internally. So I'm giving my own hash code value. So here, instead of 5, I can put any object, right? New hash code value object. This constructor I'll take. I have a parameterized constructor, right? Whatever I'll pass here, that will I assign to this I value, and I'll return the same value as hash code. Right? Fine. So let me change everything. So I don't know internal hash code value. So here I'm giving the hash code value explicitly. For that, I have implemented my own logic. If it is all numbers, So by default, it is taking ascending order. But if it is something string, all these things, we don't know. So because of that, forcefully, I am implementing some logic. Whatever I'll give here, consider that as a hash code. Whatever value I pass, consider that as a hash code value. Okay. Now I need to print this H. I'll make it HT2. So toString method, I'm converting and giving it in the form of string. Okay. So why I have written this logic? So I'm returning I, but this value is, how can I get here? How can I print that one? With the help of toString. But it will return string value, but I have integer value. So I'm converting this integer to toString and I'm taking here. So because of that, I overridden the toString method. Okay. So here also, if it is 30, you'll get the same output. Okay. You'll get the same output. So this hash code value I implemented internally. So if it is integer value, so you don't see any differences. But if it is something else, then it will convert the hash code value to whatever value I have given. So if I try to print this one, the last one also will get the same thing. It's 23. But if you remove this 30, the first value, third value will be same. You see, first value, third value, right? So if it is integer values, we don't see any help of writing this hash code value class and returning this hash code value and converting to toString, all these things. No need, no help with the help of, means what you say, like it is of no use. Okay, it is of no use. But if it is something else, if you take key, then for that key, I don't know what could be the hash value. I am forcefully giving some values. Okay, so at present, comment this. We don't need. I'm just explaining that. So here, what we need to understand, I have taken the more capacity than what I'm inserting. I'm inserting 6 values. I have 11 here. I have 30 here, 6 values, same values. But here, different output, here different output. Why? Like this. So that we will understand. We'll go back to the PPT. So here, we'll try to understand what internally it is happening. Right. So when you create hash table, so hash table will create with this, you see, 0, 1, 2, I missed 3. Okay. But actually it is 3, 4, 5. So give me 1 second. I'll change that. So I corrected this. So it will be 11, right? From 0 to 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So initially it is 11. So I have a hash table here. Hash table HT is equals to new hash table. Internally it is 11. So I have 11 buckets. So technically we'll call it as buckets. So 11 buckets created. So I'm putting 5A, 1B, 7C, 15D, 23E, 16F. Right. So now I want to place this here. So put 5. So hash code 5. So I am putting in the 5th hash code. 5 is equals to A. Okay. This value I am placing here. Okay. Now 1 is equals to B. In the 1 place, 1 is equals to B. Okay. In the 7th place, 7 is equals to C. Right. So these are hash codes. So according to that, I am storing there. Right. So now till here it is fine. Now it became 15. So there is no 15. I have only till 10 only. So what is the logic? Key percentile 10. The logic will be like this. If it is here also, what you'll say 5 percentile 11. If you take this one, 5 percentile 11. 5 percentile means 11, 0 is a 0. right? 5. So he'll take 5 only. Percentile means this one, right? Reminder. So if you take 1, 11, 11 zeros are 1, right? So because of that, I am not doing percentile directly. If it is less than this value, 11 value, right? But when it comes to the 15, there is no 15. Then if you apply the same logic, 15 percentile 10, 15, 11, 11 1 ja 11, then it is 4, right? Then it will go to the fourth element, the fourth hash code. You see that in the 4, 15 is equals to D. Okay. And the same way 23, right? 23, 11, 11 2 ja 22. Remainder is 1. In the 1th place, 23. So you can put more than 1. 1 equals to B, comma, and then 23 is equals to E in the same hash code, right? Coming to the 16, right? 11 1 ja 11, then it is 4. In the 4th place, sorry, yeah, it is 5, right? 6 minus 1, 5. In the 5th place, 16 is equals to F, right? This is how it will place the values. So it is placed fine according to this logic. It placed here. Now how it is printing here, there also one rule is there. What is that? So from top to bottom, okay, top to bottom it is coming. So 7 equals to C first, okay, then coming here we have 2 here, then again confusion. So this order, if you say left to right, right, this is left for me, so left to right, something like that, okay, right to left or left to right. So first it has to come this direction, okay. So in that direction, 16 is equals to F first, 5 is equals to A next, then again top to bottom, again 15 is equals to D. Now when you come here in this hash code, here you have 2, again this direction. First 23 is equals to E, 23 is equals to E, and then 1 is equals to B, right? That is how it printed the values, right? So give me 1 second. Yeah, if you go to this here, you see that 7 equal to C, 16 is equal to F, 5 is equal to A, 15 is equal to D, 23 is equal to E, 1 equals to B, right? So now, but when it is 30, okay, when it is 30, then why it is different output, right? So let me clear this. So we'll go to the next slide. Right here, 30. Right. 30, same logic I have here. What I took only till 23. The reason is I cannot place everything 30 elements, 30 what you say rows here, boxes here. So whatever from 0 to 23 I took, and the above you will have 24 to till 30. Okay, but I want only till 23 I took, and in the middle also I skipped something. Whatever I want I took. Okay, so now if it is 5, it is less than 30, so directly it will go to the 5th position only. 5 is equals to A. If it is less than 30, directly it will go to the 1 equals to B. Again 7, it will directly go to the 7, directly go to the 15, directly go to the 23, directly go to the 23. If you have here 32 comma G, something like that, then where it will go, 32 of 31 ja that, then 2, then it will go to second place. When you see if it is 2, 32 is equals to G, something like that it will come. But these all keys are less than this, so we can directly place those. We have 30 buckets here already. So because of this behavior, we see different output. Now you see from the top to bottom, there is no left to right, right? Only top to bottom. So 23 is equals to E, 16 is equal to F, 15 is equals to D, 7 equal to C, 5 is equals to A, 1 equals to B. Right? Internally, the logic is something like this. Because of that, the output is different for different capacity. Okay, right? We have seen the same thing here, different outputs for different capacity. Right? That is how hash table works internally. Okay, so what could be the possible interview questions from here? What is hash table in Java? What are the different constructors available in hash table? Okay, so that's all in this video. Thank you. Hi, in this video, we will talk about properties class in Java. Okay, so this is very different from whatever we discussed till now in the collection classes or map classes, whatever it is. So it is different from all those. So, and it is very important and very frequently used in your Java. Okay, so first we'll talk about that, where it comes. It is a child class of hash table. Okay, so it is child class of hash table. So properties class is child class of hash table. Values which changes frequently can be managed using properties files. So here we'll have another file called properties files. So in your application, in your program, some values are frequently changing. So if you have that kind of requirement, then you need to use properties files instead of hard coding those values into your program. So values which changes frequently cannot be hard coded in the Java program. Each change in the source file requires recompile, rebuild, redeploy of the application, which is very costly operation. Right? You'll have so many files, so much of code. Right? For a single change, if you want to reflect that, you need to recompile your code. So that will take so much of time, as you will have n number of files and so much of code, and you have to rebuild, redeploy for that. Right? So because of that, if the value is frequently changing, then manage those values as a separate from your Java program, Java code. Okay, so for that we'll use properties files. We'll put these values inside the properties files. So example, your database username, database password, some application URL, right? So you have database username, you hard coded in your program, right? So because of some reasons, so every 15 days, every 1 month, every 45 days, you need to change your password or username, something like that. So if you keep changing for 1 month or 1.5 months, so if you go and change this value in your program, okay, so for that you need to recompile, rebuild, redeploy. You need to do so many other activities, right? So instead of that, if you manage these things from outside of your code and you read from there, if you just, so whatever it is, it just read from the value from the other file. So whatever it is, it will take from there. For that, we don't need all these operations, right? No need to recompile, rebuild, redeploy, all this we don't need, right? Because of that, very frequently changes values, you need to manage with the properties files. To read those properties files, we'll use properties class. Okay, so to avoid these things, need to configure these properties in properties file. And properties object can be used to hold the properties which are coming from the properties file. So we read the properties values from the properties file. Those can be held by this properties object. Properties file can be used to represent a group of key value pairs where both key and values are of string type. In the properties file, whatever you mention, both key and values considered as strings only. Okay, whatever it is, it will be considered as string. Okay, so that is all about properties class. What are the constructors? We have only one constructor, that is basic constructor. Properties equals to new properties. But you have different type of methods here. So string get property, and you need to mention property name. So string property name. So it will return, obviously, key value both are, means property name and property value both are string, right? If you get that value, obviously you'll get the string only return type. So returns value associated with the specified property. Okay, and another one is set property. So in the properties file, you can write your own properties with the help of Java code. Means your own, you can directly write in the properties file. Otherwise, you can set with your program. So string set property. So one property means you will have a property name and property value, right? It set the new property in the properties file and returns the old value if the property already available. So if the property is already available, so it set the new property in the properties file and returns the old value if the property already available. Otherwise, it will set the new value. Returns null if the specified property not available. Okay. So enumeration property names. So it will return all the property names, not values, only property names. So void load. For this, we need to give input stream. So to load properties from properties file to Java properties object, right? We have a separate file. So if you want to read separate files, we need to use input streams, right? File input stream, all these things. So you need to read those data using file input stream. That object you need to pass to the this load method of properties class. So void store. This is reverse. So you need to, if you want to store properties from Java properties object to properties file. So for the set property, we need to use store. For to get the property, we need to load. So here output stream, you are writing back to the file. So output stream, and you can put some comment. Okay. These are all the methods available in properties class. So if you take like this, so typically the properties file looks like this. Okay. So property name and property value. Here it is. The file name is, you can give whatever it is. I have given data.properties. So dot properties. This is file name. Okay. So data.properties file, and here you have property name and you have property value. Okay. Username is equals to Krishna. Password is equal to password. URL is equal to some URL. Some browser I want to read, Chrome. So my browser may change frequently. Sometimes I want to use Chrome. Sometimes I want to Firefox. Sometimes I want to use Safari. Right. So don't hard code this one. Because of that, I'm reading from the properties file. My port might change frequently. One time 8080, 0808, 8881, something like that. So because of that, don't hard code these values. Put in properties file, read from here. If you want to read all these values from properties file to your Java properties class object, this is. So then you need to use load method. Then this entire data will be loaded to this object. Okay. And the same way, if you want to store some values, set some values from your object to this file, then you need to use store method. Okay. So this is what the behavior. Okay. So by taking one example, we'll see. So let me clear this. So let me go to Visual Studio Code. So here I created one class called properties demo, and I have one properties file called data.properties. You see that I created data.properties. Username is equal to Krishna, password is equal to password123, browser is equals to Chrome, port is equal to 8080, URL is equals to this one. Okay. So now we need to create one properties class object. Properties P is equals to new properties. Okay. But I need to read the data from the properties file, right? So for that, I'll use file input stream. FIS is equals to new file input stream. And you need to pass the path of your file. And it will throw exception, right? Throws exception. And if you want to use file input stream, you need to import java.io.star package, right? So I need to provide the path of my file. Now here my properties file, my Java file, both are in same location. So then I can directly give file name data dot properties. If it is somewhere location, you need to give that location. Okay, location of the file. Now you need to get the values from properties file to your properties object. For that, what we need to use? P dot load method. P dot load of file input string. Then this object will hold all the values from the data dot properties. Now whatever value you need, you can get that with the help of property name, right? So first we'll try to print this one. System dot out dot print ln of p. Okay, so print ln of p. Now go to your command prompt. So here, so what I'll do, first I'll execute. Okay, Java properties demo dot Java. You see that password is equal to password 123, port is equal to 8080, browser is equals to Chrome, URL is equal to this one, and username is equal to Krishna. Insertion order we cannot predict, right? So this is how it is giving me, right? Let me copy this and just paste here. Okay, now I want to read only specific value. I want to read only specific value. So that time what I'll do, string property is equals to p dot get property method, and you need to mention what? Username, means property name. Then system dot out dot print ln, I'll print the property, right? Obviously what it will do, will verify. So here what I'll do, first I'll compile. Okay, first I'll compile and I'll execute. So Java C properties demo dot Java, properties demo dot, and compiling. Okay, so I'll run Java properties demo. You see that I got Krishna, right? Now I go to this one and I'll change the username to Sakinala, some other name. I changed this. So if I run this one, I'll not compile now. I will not compile now. I'll just run this one now. You see that I'm getting the new value Sakinala. But if it is same thing, if I change here, let me do this one. String username is equals to Krishna, system dot out dot print ln username. Okay, just like that. So I have written something, I need to compile. So I compiled, I will run. Okay, I got Krishna here, right? So I changed here. Okay, I changed here to Kumar. So if I try to execute now, just execute, not compiling, you see still I'm getting Krishna. The reason is, if you change something here, you need to compile again. Then only it will reflect. So I compiled again. If I run now I'll get the Kumar. You see that? That is the difference. If it is simple program, it compiles simply. But in real time, you'll have so much of code, so many files. So to compile that entire project, it will take so many hours sometimes. So because of that, so manage your values from here. Then no need to read without compiling. You execute it right now. Right? That is the advantage when you read from other file. Okay. So this is how I'll get the property with the property name. If you want to set something, okay, p dot set property. Okay, set property. I'll put language, property name, property value, Java. Okay, just one random values I'm giving. So for that, I need file output string. So I'm writing outside, right? For FOS is equals to new file output string, and you need to mention the file path. The same thing, data dot properties. Okay, data dot properties and p dot store. If you want to read, load method. If you want to write, store method. In the store, you need to provide this file output stream object, and you need to give some comments. You can simply leave that, but adding new value called language to the properties file. Data.properties file I can give. Okay, that's it. Now Java properties demo.java. I'm directly executing this. Okay, so now you observe here, there is no comment, nothing here. I do not have language is equals to Java. Now I'm writing to this file from the Java code. So let me execute this. Sorry, demo.java. Now, if you go to data.properties, you see that it added language is equals to Java, adding new value called language to the data.properties file on which date? Okay, Friday, March 11th, 2022. Right. So, and the order is also changed, but we don't know how it will be. So it read the data and it is dumping into the data.properties. So its own logic, insertion order. Right. So that's how you can store some values to your properties file. Right. You need to, if you want to read, you need to file input stream fi is equal new file input stream of that path of the file and p.load of file input stream object. Then you can use p.get property of property name. You can set using p.set property, and you need to store that values. Okay. So this is all about properties class, and very, very important. Right. So this is all about properties class. Okay. So what could be the possible interview questions from here? So what is properties class in Java? What are the different constructors available in properties? What are the methods available in properties class? Okay. So that's all in this video. Thank you.